Pretty sure I'm now streaming.
I'll stream our workboard. What's it called?
Miro. How have you pronounced it?
Yeah.
Am I streaming? Ah, there we go. It do be working.
You just stop.
Good.
Oh no.
It do be working. Oh.
Timer. We'll have set the timer at 3 intervals of 90 minutes, which is quite sad, but there we go. Because
Wait.
Underscore Daniel 1. Will you be streaming like the YouTube?
Right.
Oh, sorry, I forgot. I need to continue streaming this.
It's Among Us.
Yeah. Ooh. Wow. I'm gonna have to get the questions up. That's gonna be really annoying.
Yeah, I'm getting the questions.
Post on Myra.
Yeah, I'll
Oh, okay.
Yes, Danielle.
What are we doing about the playlist?
I just tell me when you want it and I'll play it.
Okay.
Yeah.
We put on music. Should I put on Polish Toilet Spin?
No.
Unfortunately, I've edited the rules so that only I can change the music.
Ah.
And the playlist is 4.5 hours long anyway, so it's fine.
No, but you can like skip it. So.
I have posted question 1. I just need to make it bigger now. There we go. Question 1's on the board.
Hang on. Question. Is
Yes.
Mood Organ on the playlist?
Yes.
Yes, Mood Organ is on the playlist.
All the songs?
No, just Brain Tourist, sadly, because when I made the playlist, I didn't realise they released other songs.
Oh, they released an EP.
I know they released an EP. Okay. Wait, hold on. Who's put the problem in? Who's put the problem
Oh,
in before
sorry,
we started?
my bad.
Delete.
That's why you don't have That's why you don't have the board open before you go there. You don't have the board open and you can't.
Yeah,
Well,
I'm not got the board.
I just stream it, so.
Wait, how do you know
Okay.
they were the IMO problems? 2 is a whole number. That seems a bit sus.
Yeah, how do you know that? How do you know that? That's a bit sus, mate.
Okay.
Oh wait, this is the wrong whiteboard.
Wait, should we change that now? Should we change our name to Livesolve 1 and Livesolve? Nah, it's fine.
No, it's fine. Okay. Hello, everyone. Welcome to the Livesolve.
Oh no,
We'll hopefully be able to entertain you as much as anything else.
Wait. Oh wait, did I
know.
get the wrong link?
Still
What is
a
this?
minute away.
Yeah, you're not
Yeah.
on the whiteboard.
Inverted Abra Nemesis XD. Do you mind shuffling the playlist as well if you're able to do that?
Yeah.
Good.
I'll play it right now.
Hang on.
Yeah. And shuffle. There we go. Right.
Wait, is the board blank? I can't see anything on it.
Yeah, it's
Board
ready
should be
blank.
yeah.
Apart from things I just drew on it. Okay.
Right. It's 20 seconds.
I don't know how to do. Oh, that's the rubber. Okay.
15.
I'm just zooming in. Where are we gonna start?
Okay. Just put the link in.
5,
4, 3, 2, 1, begin.
Alright.
Okay.
Wait, where's the problem?
It's not.
Yeah, put the problem in.
Yeet. Problem is now on the board.
We can rhythm down. Wait, maybe read a bit.
Oh wait, that's huge. Okay, we're gonna have to zoom in.
Yeah.
Oh,
Yeah,
I
you can zoom in.
zoomed out a lot, I think.
Yeah.
Are we gonna go for them sequentially? I think we probably should.
Yeah, because
Yeah,
problem
I mean,
1 is easy, but problem 2 and 3 are nightmarily difficult.
Yeah, given the difficulty of 2 and 3, I think that's probably correct.
Okay, so, he shuffles the cards and divides them into 2 piles, prove that at least one of the piles contains 2 cards, such sum of the numbers is a perfect square. Okay. Can we use Bertrand's postulate here? Because there must be a prime in there somewhere.
True, that's true, there is a prime.
he divides them into two piles. It doesn't say that they have to be like the same like size or something.
Yeah.
So.
Okay, well, n is larger than
I mean-
100 means we have some nice bounds. So, like,
N larger than 100. That's a weird thing to like have.
Yeah, there must be some sort of weird contradiction that happens if you have lower values of n.
well,
No, it might just be to get rid of any like weird edge cases.
yeah,
mean,
your weird edge
like
case
if-
would be because the difference between squares is usually like 2n or something. So all that's saying is you can't have a very long series of consecutive things within the same block, or you get a problem. So
I'm wondering if 100 is the bound and like they just put it basically.
no, it's not. 100 won't be the bound. The bound will be like 3 or something,
Yeah,
or 3 or 9 or something. Sorry,
they've just chosen the 100 to get rid of like any sort of doubt.
Wait, I'll make my pen thicker. What my?
Recently having some technical issues.
There we go.
100.
Okay, I'm just gonna spout
Yeah,
stuff.
if we
do you reckon they've put 100 in so that you can't try small cases?
we can try
It's
small
like-
cases.
If you let any
100 being in
three-
there does not mean we can't try small cases.
Yeah, I mean, probably good just to try some small cases anyway. Like, yeah.
Okay, n equals 3. Wait, you've either got 3 and 6 or 4 and 5. They've got to be in different
Yeah.
things, and there that breaks. So it's not. So 3 isn't the bound. Sad.
No, leave it on the board.
Yeah, so 3 is not the bound. I mean,
Oh, of course. These
4, 5, 6, 7, and 8.
4, 5, 6, 7, 8. Well, that won't
we
work
have to
because that only means you can put 4 and 5 in separate piles. They're the only ones that work. 16 the next one up, but that's 8 and 8, which doesn't work.
Yeah.
Yeah.
So that definitely doesn't.
Wait, is there an undo? There is an undo button.
Yeah. So the bound's probably going to be something like 20 or something stupid like that.
Okay.
Again, can't trust more cases.
Can we do some weird combinatorial argument by saying, oh, each number has so many other numbers that it can't go with?
I mean, probably like surely if you can find 3 integers that like each pair of them adds up to a square number, we're done.
Well, that's gonna be quite hard, surely.
Okay, so maybe we should look at. So if I find if we have a square number there, then we have to do like opposing ones, right?
Wait, what do you mean?
So if a square number is say something dumb like what's an easy one? Like 2n plus 7, we should probably base it off 3n realistically, but that's fine.
Because
then we have to split it 2n plus 3, 2n plus 4, 2n plus 2, 2n plus 5. Like that's one set and that's another set. Yes.
why? Oh, are you talking about 4? You mean 4 plus 7?
Yeah. Okay. Well, I
like
didn't mean to write 2n, but it's kind of irrelevant.
Yeah. Okay.
and
Fine. Yeah.
All we need to do is prove that 2 of those splits exist, and then we're done, right?
I mean, yes, but like if we take 100, our minimum possible sum is 201. Our maximum possible sum is 399. So we have
no, it's not 201 though, because it would need to be 2n plus 3, right?
No. I'm saying like the minimum possible number we can achieve is 201.
Oh no, it would have to be 201. I agree. Like if 201 was a square, that would be an issue. So all we have to do is prove that between 2n plus 1 and 4n minus 1, there'll be at least 2 squares.
Yeah.
3n minus 1. Wait,
No, 4n minus 1.
It is 4n minus 1.
Yeah.
So these are our squares of interest.
No, Reese, it's a very simple bounding argument, right? Like the difference between squares is 2n plus 1, and if that's like n squared,
which is like where n is significantly less than where like n is significantly less than the number we start off with.
Yeah. Okay. So there will be a square number between 2n plus 1 and that, right?
Yes.
Yeah.
That's like.
And there will also be between the square root of that thing, 2 times square root of that thing plus 1 to that. So all we need to do is prove via some scuzzy bounding argument that is less than 4 and minus 1, right?
Yeah. that
Wait,
kinda
you
makes
cut out
sense.
there.
Or we need to do...
Reese,
Oh, no,
look to the-
that's not true. That's not true. It's not true that 2 square numbers is sufficient to do it, is it?
I don't think.
No, it's not true. It's completely not true. I'm a fool. Say those two square numbers are 36 and 49. You can put one. I can't think of good examples. Say they're 81 and 100.
Yeah,
then
but you
you
have to have odds. So you have to have odd square numbers, don't you? Because otherwise, if you get an even, you've got like I suppose. No, never mind.
No, 2 being the same wouldn't be an issue. 49 and 51, and then.
Oh yeah, because we do with 100. So they've got to be in different ones. 48 and 52 have got to be in different ones. And basically, you can find where that you can just link up.
No. That's what I'm saying. I don't think you can.
No, because you can just
You can just have them. You can just have
that's
them
what
in
I'm saying.
difficult
It's
ones.
probably a good idea to find if there could be 3 integers that add up to the square numbers. 3 integers that mean a difference of 2.
So you're going.
Hold on, so-
hey,
so-
literally try to find. N is a bad one to use.
Could you just kind of take some simultaneous equations? So
Yeah.
they don't have to be consecutive
No,
squares.
no. I know. I'm just trying to think of some construction that would work.
Well, yeah. So, construction thingy wise, you have n. You obviously have m to 2n to play with, and you can have negative things as well.
Really, okay, if you have an integer k and some m's that's in the range, some m's the m squared is feasible enough so you can add something else onto it. If you take k, then you take the integers m squared minus k and basically m plus 1 squared minus k. And you've got 2 of them that you've got these add up to a square, these add up to a square, so you only have to show that these add up to a square. Which becomes
that's going to be you have to prove that exists for one specific m and k.
No. Yeah.
That's
so
what
what do you got? So you got 2m squared plus 2m plus 1 minus 2k, right?
I highly doubt that's going to be a general thing. I highly doubt it's going to be.
Are we doubting that? I mean, the only thing is that it's 2m, which is
if we can
awkward.
prove that is a square for some values of m and k, then we're done.
Yeah, I mean, the only thing is that, of course.
Then eventually, right? You've got to make sure that both of them roughly lie in the range that we need.
Well, no. That's okay, isn't it? Because k should be approximately m squared. So really, k should be m squared minus something, right? K squared.
I mean, hold on. Yeah. If you set k to be
m squared minus 2m.
half m squared minus 2m.
Oh yeah. You want it to be half m squared. That's much better.
Half m squared plus m. Because then, that becomes you then end up with m squared minus. Wait, no, sorry, it is 2m. Because then, if you subtract that, you end up with m squared minus 2m plus 1. So if you have these integers, half m squared plus 2m, then m squared take away that, which would be half m squared minus 2m, and then obviously for some even m.
Yeah, the other thing.
And then what else was there? It would be m plus 1 squared minus that, which is just add 2m plus 1 onto that, so you end up with half m squared plus 1.
Yeah.
Then
we're done.
Yeah. Yes. So just prove that for every n we've got, that there exists these that work. I'm pretty sure it's going to be quite difficult.
No, not at all. For the exact same reason we said before. That is proving that there are 3 adjacent square numbers, right?
I mean, are they adjacent? Yeah.
Yeah.
No.
Oh wait, no.
Yeah, no, it doesn't.
No, it's proving there are 3 adjacent square numbers, a distance at half m squared up on the number line.
Yeah. So if we have these here, we just again we just but surely for like the range between these numbers is obviously 4m. So we want to have it such that
we need to prove that that one is less than double that one, and then we're done.
Yeah, which obviously
right? No,
not necessarily. You have to find that for every you have to find some integer m such that 4m is less than or equal to n, right? And probably it's going to be less than. 4m.
So you want 4m being less than or equal to n,
no, hold on.
Also...
But that breaks later on because you have to have like m squared, like m squared to be roughly equal to 6n, haven't you?
Why? No, because that's m. That's all m there.
Yeah, I know, but I'm saying that you want to have m. So you want to have such a Oh wait, yeah, sorry, yeah, but we're between m and n, like that.
Yeah. So say we have n equals 20, or n equals 20 or something. What are the appropriate? So if we're 20 up to 40,
such that half m squared plus 2m, where m is even, you'd probably want m equal to be 6. No, that gives you no, that's too small. M equal to 8 doesn't work either because that's too big.
Okay, well no, that's interesting because that suggests that n being around 100 is a reasonable bound.
So if you let n to be 100, you want to find such that half m squared is roughly 150, which means m equals roughly 300. So I'd go for m equal to 18. So you'd get 324. Half that is 162.
Okay. Question: Can we just double everything so we have nice numbers to deal with, please?
Wait 1 second. I claim that m equals 18 works with that. I say the numbers 196. Wait, no, 196, 198, 163. Did they add a square number? Yes, they added 361. And half of 160 minus 36 is 126. There you go. That's those are our three numbers that break every time.
Okay, Reese, is that right? So we can just double everything, and we want to prove that we have m squared minus 4m, m squared plus 4m, and m squared plus 2, in those within those numbers. Because obviously, if they're in between those numbers, then we can halve it.
Wait. Not quite. No. I'm not quite sure that works because.
No. If they're between those numbers, then half of them are between m and 2n, and they're also all even.
Yeah, but they're not all even if you look at them.
They're not all even necessarily, so we say 4m even. That makes it harder to work. That makes it harder to prove, but that's okay. Yeah. That's not an awful plan.
So you want to say so then you just say, well, if that works, then that works for all n up to 126. Then for the next one, you have to try. Wait, hold on. Let me zoom.
Well,
yeah.
That's
because then so now then you just try the next m that's up. You try then you try m plus 2, which would give you Does that work for if you go to? Let me just erase some of the stuff. I wish I could erase stuff that. Oh, wait, you can set things, don't you? Oh, oops! Didn't mean to do that. Oops. I don't delete everything. Just delete that. So I've got room.
Okay, Reese. If we can prove there are at least 6 squares in between every 2n and 4n, actually not 2n and 4n, but between 2n plus 4 or 2n plus 5, sorry, and 4n, then we're
wait, no, I think if this gets too big, we get into trouble pretty quick. Wait,
Oh no, wait, m has to be.
So 240 take 80
7.
away from that. That's 160. Set it to 400, and then 201. That works if we were to take 126 and then like. So you can just inductively keep going by saying that
you have to you'd have to prove that this number is less than.
Yeah, all you have to you just have to prove that half of m plus 2 squared, mine plus 2m plus 4, is less than or equal to 2 times. Yeah, which is just like 2 times half m minus 2m. So that becomes. I wish I could move down. How can I move down?
That's gonna be.
Just scroll down.
Yeah, I'm on a drawing tablet.
Plus 4m.
Oh wait, how do you move down? Just scroll down.
Right click the cursor button. Double click the cursor at the top left.
Oh yeah, thanks.
Okay, I think I proved it.
4m. That becomes.
Oh wait, but then like that breaks for. No, because that didn't like. Oh wait, no, that's right.
Yeah, I mean, if you can get a bound here.
Yeah, there we go.
Yeah,
I've got an awful bound. An awful bound of m is.
So like, you can just.
I've got an awful bound. I've proved it for above 150.
I'm pretty sure we've proved it for like. M squared. What's that? M squared minus 16m minus 12 is.
Oh,
wait,
I used m squared.
No. You've. It just should be minus half. Mine should be minus half m squared.
That should be greater than as well. That should be
okay.
Yes. There you go. That's where we went wrong. So what's it? Half.
That's for m is greater than or equal to.
Like 7.
Square root of.
Just call it 7. Just call it 17.
You mean mod of m?
Yeah. I'll just make that the plus then.
Yeah. Okay. Reese, we're done.
Yes.
We're done. If you prove special cases up to about 150, then we're done.
Because like we just say consider the card. Should we write up solutions as well?
We probably should.
Really?
Wait, have I done something stupid? Oh, that's 12. That's 48. My bad.
Yeah.
That should be.
Yeah. Okay, so my solution on the right-hand side
12.
is just prove that there are at least
28?
7 consecutive squares between 2n plus 4 and 4n plus 4.
I mean, what was it? M squared minus 16m minus 12 is positive. Can you factor that? You can't factorize that. Yeah, just look at the critical values, which would be 16 plus or minus b squared 256.
17 works. 17 works.
Wait. 17. What do you mean by 17?
Well, if it's m squared minus 16m minus 12, m has to be 17 or higher.
Yeah. Oh, and and for m greater, we're looking at m 18 or higher, so we're fine. So actually, yeah. So yeah, we're done.
Yeah.
Wait, I'm very confused. What have you guys done?
Okay, so my thing on the right is basically the same thing as your thing on the left, but like slightly different. So wow, great description. So I've said that if these numbers in the red box, which is now also a line box, are between 2n and 4n, then half of them are between n and 2n, right?
Yeah, that makes sense.
So that's cool and everything. And then they will be between, for m even, and they will be between them
if
there are at least...
just done what we did.
Yeah, if there are at least
7
consecutive squares between 2n and 4n.
Yeah, and that makes sense.
Yeah, we do a cool thing.
Okay, now, I'm really happy that we solved problem 1 early. Bad news is that means you have to move on to problem 2.
Oh boy. Okay.
I haven't seen problem 2 yet, so
I shall screenshot.
No, I'll screenshot it.
Problem 3.
I've already got it, please. So.
Okay. Let's leave the working up somewhere and just scroll down.
Wait.
Do you wanna click on my picture at the top and teleport? To
we
don't want to spoil it for other people, so maybe we should move problem 2 down a bit. And what is that?
Yes, exactly. So that the inequality.
Oh god. Oh my god.
Okay. Wait. I can't see me. Let me zoom in. There we go. Okay.
So prepare for death.
So first of all, like why, like in both years at the IMO in Russia, problem 2 is some manky inequality.
Oh.
Okay. So let's try. What are you going to try here? Koshi?
Small cases, Reese. It's always small cases.
Yeah, I know small cases. So let's try x1, x2, x3.
What?
Actually,
X1, X2. X1, X2 is a small case.
Okay.
So we have this group.
So the left-hand side becomes square root of mod x1 minus x2.
Okay,
plus
small cases are a thing. Vectors are a thing.
0, like it dies there. So plus. So
wait,
it's just
two lots.
Yeah. So the left-hand side is this, and the right-hand side is like
the
two
same.
lots of.
It's just the plus.
And then plus like twice, or plus square root of 2, so like square root of 2 x1 plus square root of 2 x2 mod x2.
Yeah. Cool. Yeah.
If small cases and Geo die, what else do we try?
I mean, like it hasn't died yet.
Do we just take the bait and square everything?
No.
No.
There's 4 square roots, and
No.
and also like I suppose everything's positive, so it's fine. Should we move on to problem 3?
I'm tempted. Question 3 the Geo.
No.
Means it might.
No, okay.
No.
Let's not give up so easily.
Okay.
So we have. I mean, like, how do you even go about to proving that?
What is this?
It looks like Geo. Like if they're all vectors.
I do have to ask, what is this song?
It's from Chicago.
Oh, I have it muted. That's a bad. I will turn it on.
So I mean, for positive numbers, that's pretty much trivial, right? Like, of course, this is gonna.
Yeah, because
that's gonna be bigger than that.
If x2 is actually if either of them if either of them are positive, we're fine, right?
If they're both negative.
If they're both negative, then you can just swap them with their positive.
Then we're still fine. So it's like the only case.
If they're both negative, we're fine. If they're both positive, we're fine.
So without
if they're opposite, then we're also fine because one of them is bigger than the other.
Yeah, wait, yeah, that's because the absolute
because
triangle inequality, isn't it?
Oh no, wait, it's root 2 of something, so that's just.
Oh yeah.
Okay, so I mean, equality holds when x1 equals minus x2, right? Or vice versa. Well, that makes sense.
Equality doesn't hold. Equality only holds when they're all 0, I think.
No,
wait,
I just tried 1 and minus 1. You get equality. You get both.
Yeah, that's true, right?
So equality holds when this, for sure. You just get 2 root 2 x1. On both.
That's true with equality case holding when they're all equal, and so therefore if they're different, then like the one that's bigger beats it, and the two that aren't bigger, well, like square root 1 minus root 2 minus 1 of that isn't necessary, but the other bit is, right?
You know, some guys just can't hold their arsenic.
Sure.
Oh wait, I'm thinking. No, you need that all. Well, okay, so what I'm saying is that this number is equivalent to that number plus that number in some scenarios. Like, x1 is negative and x2, or like x1 is positive and x2 is negative, then this number is equivalent to that one plus that one. But that thing exists.
I'll try to take your word for it. This is...
No, you can't take a word for it. That's like not the point.
Okay, I might not be listening, so say it again.
Okay, so we'll log x2.
Okay. Yeah, mod of x2's when. Oh, because you don't. Yeah, you're doing with modulus.
And x2 is negative.
Wait, no, you can't do that both times, can you? You can do it. You can do it once.
I'm pretty sure I can because I can just change them. I can just change the minus sign in the bracket if I want. It's a different kind of log, but I can change the minus sign inside the modulus.
Like,
okay.
Oh yeah, because in the modulus on the left hand side you can flip. You make both of them minus and it's fine, and in the same one you can. Yeah, that works. So the mod of x2 is
then we
mod of x1.
Have x1 minus x2 in a bracket, and we have x1. So then we call let y2 equal minus x2. Then we have x1 plus y2 over here, and we have x1 minus y2 over here, and we have 2y2 over here. But
be careful because you're doubling the square roots on the left hand side.
It wasn't until later.
No, but that one is dealt with by this, and the other one is dealt with by 2x1 being bigger than x1 plus y2, right?
Yes.
Okay, and that's actually pretty strict, right? At least that is not. Oh no, that's not that strict. We have two AB, so one can be 0 and it's fine. Alright? Okay.
Again, I wasn't listening. I'm too tired for this, but sure.
Okay, well,
I'm too tired for it, and it's 3:28.
We've just proved the two variable case.
Yeah, I mean, I think can that be generalized to more variables?
Not really, because once you introduce three variables, because when you introduce three variables, you have 9 terms on one side.
No, but that's okay.
Can we have all questions from the audience in the Livesolve chat, please? Thank you.
No. Aaron speaking is useful.
Thomas, you just applying the inequality square root a plus b is less than or equal to square root a plus square root b.
Yeah, I know.
And you're not using the fact that you have a square root x1 plus x2 term on the right.
Oh, no, wait. For this one...
Sorry, maybe it is fine. Sorry, maybe I'm just...
Yeah,
Yeah, I see what you're doing. Yeah, that's probably fine. I'm tired.
Thank you. Thank you very much for the interruption that was, removed. Yes. Okay, so that's okay. Now...
So, two variable case, fine. And without the generality...
involves, weird...
It's not fine, it just involves manky inequality.
We didn't make it work nicely, which annoys me.
When you have to bash a single case, it doesn't bode well.
I got a chat from someone called Fred in my live stream saying, "Oh my god, such a tune."
Is that Fred from the cam chat? I bet that's.
No, you're not allowed to check for live stream chat because it could have spoilers.
Yeah, that's true.
Okay. Can we make some argument about optimal negative? No, we can't.
Oh yeah, by the way, I should have said that this is being live streamed on YouTube, so if anyone in the audience wants to speak, then you speak knowing that that's going to happen.
I mean, they can't speak, mostly.
I think most of the audience can speak.
Yes.
Okay, so what about geo things?
You want to use
Yeah, I mean,
geometric algebra. So,
I don't. Part of me is like, I don't feel like there's going to be a geometric approach to this, just because.
I mean, like how do you
because there's a GeoQ4. But yeah, we can try
it's
it.
like square roots being annoying, right?
I mean, like if you. I suppose you can generalize it like by saying that like if you use just like Pythagoras and stuff, like if
no, because there's a square root in an irritating place.
Yeah, I don't think Pythagoras is going to do it.
Like what else? I've forgotten the Cauchy-Schwarz inequality, but that might be useful.
Having said that, if you let all the xi be, have n dimensions,
Oh, gross.
I dive and try to explain to me the n-dimensional hypercube in
have
like,
n dimensions, and then you struggle to do the minuses. That doesn't work.
yeah.
The right hand side works nicely. The left hand side does not.
Well, just like, well, like, can you generalize it by just saying that like, if you have a seat like if you got a sequence x1 x2 up to xn. If you define the sequence y1 to yn of just yi equals minus xi, then like it becomes a slightly nicer inequality because you've got like double sum never make it a nice inequality, but like you've got I equals 1 to n, j equals 1 to n of square root of x1 mod xi plus yj.
So what you're saying is, if you take the subtractions of all the inequalities, it still holds, or all like the moduli.
I'm saying that like just to find a new sequence to make it look nicer.
Okay.
Oh yeah. Can if someone hasn't already, can someone put like the problem with looking at the life solving chat?
Yeah, sure, we'll do.
I'll do it. It's fine. I've got it copied.
No, wait. Isn't that geo thing?
So do I, Reese.
No. Isn't that geo thing like very, very used? No, it's not.
What geo thing?
I was just thinking Pythagoras, like literally just n-dimensional Pythagoras it, and then for the
No,
for the left
it doesn't
hand
work.
side.
It doesn't work if you
For
end
the
up
left hand side, you can't do that, but you can just say, or you could just put them on different sides. You can not project them. I don't know. You can just like take the sum in one dimension for that left hand side because that's the obvious way of doing it for that side, and hopefully it would just squash nicely. Like, the right hand side is constant. No, it's not. I'm a fool. I'm an absolute fool. That's fine.
You heard it here first. He's a fool.
Okay, well, the only reason why there's a difference between the right hand side and the left hand side is differing is like it being really awkward to have negative stuff, right? Because if you have like, I don't know, if they're all the same and you have like p of them are negative, then you have good things like 1 minus 2p plus p squared plus 2p squared of the time.
What?
Oh well, the reason that the right hand side is bigger than the left, in my weird mind right now, is that when you have negatives and positives, like they clash and produce smaller values, just less on average than they reinforce each other and produce bigger values. Is that right? Is that even right though?
Like it's an inequality that looks like it makes sense, but it's one that's like just disgusting.
No. Well,
yeah, like I see what you're saying. That like the fact that if you have like negative ones, then like the negative, like if you have two negatives, they're going to combine together to give you a positive result anyway. It's going to give a bigger result than what we had initially. If you got one negative, one positive in there, then like that's covered on the other.
Hang on, can we induct? Wait, I know that sounds really just bold, but we can divide. We can divide everything by like square root of xn, right?
No, because then like that gets stuff in the bracket, doesn't it?
No, if we divide everything by square root of xn, don't we just get the same sequence, the same inequality, but
Plus
with
one.
like a 1. So we could say if it's true for xn minus 1, and then we prove the case with a 1 separately, then we're okay. So
I mean,
so we could induct on it, and I'm going out further to the right because that's like the way I want.
Yeah.
I know the way I want to do
I
this.
mean, I'm
Then we
I'm
could
following
say,
around. I don't even know. I
like root x1 minus 1. Wait, that shouldn't have brackets there.
no, and this should be moduli on the inside of the
Oh, who cares about moduli? We're always working.
x2 and x squared.
Shush.
But notice how that. No, it doesn't work. Never mind. I don't think like because you see you'll be. Where's the mouse? But remember the fact that if we're summing over I and J, you're going to get those repeats.
I've done that.
I think he has dealt with those.
So is that a thing we wanted to prove? Because if we can prove that for all n, we can just like divide by root xn and then multiply by root xn afterwards.
That's like the equivalent of adding 1 and then subtracting 1.
Yeah. Oh wait, we get an extra plus root. We get an extra plus root 2 over here. And just plus root 2, not 2 root 2.
Wait, yeah. If we generalize the inequality by like say if we can generalize the inequality by saying that like if it holds for any n reals and then like with 1 in there as well, because you've already got your set of reals on this side, you only have to care about the extra n squared that come along at the end, right? Like or some
Yeah.
because you've got your first term and that inequality holds. So you only have to show that like so with some fixed, some from I equals 1 to n, and then some from j equals 1 to n. But like you've already got xn fixed to be some number. Wait, there should be 2 summations in there. Because you're adding on when it's hard to think of when to you. That works, right? If we're inducting, which I don't think we should induct, but
actually, we might not be able to do this.
probably won't be able to do.
No, we can because at least one of them, because if not, then at least one of, no, we probably should, I probably should leave the moduli sign in because I kept trying to think of.
If we're trying to induct, doesn't the question literally just become doing, y equals 1 to n of root x n minus xi? I'm trying
to think, did it do that? Because then, but then you double it because you have to think about when it's x1 minus xn. But yeah, so it's like it's double at the start.
Yeah, but you can also just divide everything by square root of xn to get 1 instead.
And you could leave.
Is it just this? But then divide everything by 2.
And also divide, if you divide everything by square root of xn, you just get square root of 1 minus x1 can like be x1 over xn. Wait, no, it's still something to n. Although
no, but like really the other, I've done the n terms separately
because it's taken out the n term.
But be careful, the n term on the left hand is 0.
Can you say this is true by induction? Because by the induction hypothesis just makes xn the n minus 1 number of induction.
Are we doing?
No.
We're doing double. No, we can't double induct. You're right. If we let x equal to 1, then we've only got one variable to play around with, like one sum as opposed to 2.
Yeah. That was my idea. We're only having to do.
Hang on.
Well,
That thing is the exact same thing as the other one, which is not cool.
what do you mean?
I don't think inducting works nicely because that's not always true.
Yeah, because if xi is always negative, then like
Yeah, okay.
Yeah, of
it's
course
much
that's
bigger
not
than this.
Inducting doesn't work nicely because if something is the same, if something is of different sign,
so
it doesn't work well individually, and you have no nice bounds on size to say that other things work. Could you consider starting from K with K, where K is the largest number of the largest one, where they're all the same size? Where largest is weirdly defined, and then consider what would happen when you add them in? No, that's weird. No,
because
yeah, I agree.
Because it won't hold further down, so you can't. Why not? It would hold further down.
But you could maybe instantly. You could maybe try an insta-solve looking at it like that.
Insta-solve and IMO problem 2, I doubt it.
Well, no, insta-solve is the wrong word because insta-solve has different connotations. But you can definitely just say, yes, x1 to xk are positive, xk plus 1 to xn are negative.
I guess.
There's going to be a lot of boundary cases when they do under x1 to xk and xk plus 1 to xn interact, though, aren't there? I feel like that's going to be quite hard to model.
Ooh, chocolate.
Bruh.
Hey, I bought it for the plane trip and.
Wait, what? Sorry.
You know what? I respect that. Just casually whips out chocolate and IMO Livesolve.
I'm trying chocolate.
If I say so myself.
There's garlic bread downstairs. I'm not gonna get that at some point.
Bruh. You guys just have food and I'm just sitting here in a small room.
I am gonna go and see if there's any garlic bread.
Just realised I haven't closed the tab that says access it with the app this whole time, so I've just been missing out on more whiteboard space. This is incredibly sad.
What?
There was the tab at the top of the screen that was you should get the app, it's better. And I just left that on the screen this whole time.
Okay.
I was missing out on beautiful whiteboard space. Well, I guess we're entertaining the stream for a minute until we come back with garlic bread. Opposite parity stuff, yeah.
Well, okay.
What Chris says.
If they're all...
Also, I heard 4 people leave and I felt really offended. No, I'm joking.
No, if they're all the same... No. They might have just left because it's not problem 1 anymore. If they're all the same magnitude, it would be cool to know at what point the effects from having them the same sign outweigh the effect of them having opposite sign. That's weird because we know they're always going to be positive that outweighs it.
If it's because it's a symmetrical sum in all x1 to xn, surely you can say without the generality the sequence is either weekly increasing or weekly decreasing.
I mean, yes.
Yeah,
that's what I've written a bit to the right.
Yeah, you can always just rearrange the sequence. It is symmetric.
So we could go because we can auxiliary sequence going, hey, it's actually x1, and we have this A sequence, because I think Z, you've already used Y. The Z sequence, it's the differences, and then everything is actually
hold on.
Yeah. Z something.
Because now if you let x1 be the smallest, then it's like x2 plus d1 x3 sorry x1 plus d1 x1 plus d2. Now we have restriction of the fact that all the d's must be positive.
No, okay, I don't like that one because we have to do d2 minus d. No. I can get that working. I like that. Is it best to go for decreasing immediately? Probably not.
I like doing positive stuff. That's
just like, I mean, if we're gonna have just one x1, just call it x. So x was
or A.
Right? Or just A, yeah. Rick, use the rubber in this.
I don't know how to use a rubber.
What you do is you press the rubber button, and then you use the rubber.
Okay, so now what? Now have we made it any better?
I mean,
we're summing 2A.
It's always gonna be 2A plus. Yeah, can we say D0 for just A? So DI plus DJ. The sum from I to J. Also, sorry, from I to N and J to N.
Wait, that's the last one.
That's the sum. It's the other way around.
Wait, what's that say? Like.
Just flip the sign around, bro. Literally just flip the sign around. It does not matter.
Oh no, wait, it's DI minus DJ.
So wait, so what is it? So our first term is. Is it? Yeah, this just becomes DI minus DJ. Mod of that.
Yeah. Does that make this problem easier?
Okay, something cool, I think, is that's reversible, right?
What do you mean?
What's reversible?
Well, A can be anything.
A, yeah. And DI and DJ both positive.
So, like, if something breaks, like, we don't care about the starting point.
Wait, hold on. It's obvious that it holds, like... I think it's obvious that if x1 to xn are all positive, it's obvious that the inequality holds, right?
Mm-hmm.
Yeah.
But notice how on the left-hand side we have DI minus DJ, which therefore that is I don't know. But I think
rest in peace.
But like
also.
the left-hand side is very similar to the left-hand side of our actual inequality.
Yeah, I mean, it practically is, right? This is effectively the
Like
same thing,
it's
just with the 2A added on the right.
Yeah, the 2A and then we also have the DIs and DJs were positive. So all we need to do is really say that, like, what. Can we say we try and pick an A such that it doesn't hold, and we find that it
yeah, like trying to find the worst A is a plausible thing because there is
if you want the worst A, you'll make it 0. Like,
no,
the
because
question literally has become proving the original question.
No, like it can't be 0. Like you want A to be like as negative as possible, but like not so negative that such that like every term is negative and the absolute value just like bumps it all back up again.
Yeah.
It's like if we have our DIs and our DJs or some of all of that, we want the A to be such that the total is as close to 0 as possible. Wait, hold on.
Isn't the question literally just a subcase of this? Aren't we generalizing it here?
We're not generalizing it because we're saying DI and DJ. Yeah,
but only
we're saying
just established that if you have the sequence 1, 2, 3, 4, 5, it's the same thing as the sequence 3, 4, 5, 6, 7.
But we've defined DI and DJ to both be positives, and we've actually got a special case of our question. All we want to do is try and pick the worst A such that it is whatever it is.
I see, because I and J are all the D's are positive. Yep, okay, that makes sense.
We're just treating lots of cases the same in exchange for getting some cool stuff.
So we basically want to pick our worst A, but the trouble is that the square roots make it suboptimal.
Wouldn't the worst A be theoretically you take the average of all the DIs plus DJs?
Yeah, I thought.
Yeah, but what kind of average? Is it geometric?
No, arithmetic. I thought that, but then the square roots
0.
But the square roots make it might make them worse.
No.
Right?
The arithmetic would be awful because it'd be positive.
Why is that awful? It's going to be positive in the end anyway.
We want A to be negative.
Oh yeah, you take the negative version of the half of the arithmetic mean.
The negative version of the arithmetic mean of the whole thing divided by n over 2.
You take all the DIs and DJs, find the arithmetic mean divided by 2 times -1.
No, and then sure, okay. I can't think better than that.
Yeah, but then that still doesn't really work because the square roots mean that I can't explain it very well, but obviously if we're just summing them all, it would be fine.
No. I don't think it's wrong because of the square roots. Square roots maximize difference from established thing, so we want to minimize the distance the big thing goes, which means numeric means probably better. No, because we're comparing it to adding stuff afterwards. I don't know. Whatever it's going to be hard. Wait, is calculus useful here?
You dare?
Bruh, don't even.
Well, we're trying to minimize something for fixed di d1 to dn. It does have modulus stuff in it, but that isn't that much.
Isn't the fundamental rule of calculus don't differentiate anything with the modulus side of it?
Okay, no. The modulus sign is okay. It just means that we might have a -2 or a +2 in front of it, depending.
I really don't want to use calculus here.
Hi. Wait, no, you didn't even say I'm. That's so sad.
What's this?
No, nothing. I tried something and it failed miserably.
Lovely.
That wasn't calculus.
Okay. I mean, I suppose that. But what would you differentiate it with respect to?
A.
With respect to A? I suppose, yeah, because if DI and DJ are fixed, then I guess that works?
Yeah, the issue is that whatever sign, if the modulus makes it negative, then it did the foot in front of it does become negative.
Exactly. So it's. I mean, we can say that A is negative, right? Because if A is positive, it's it dies. It's easy.
Yeah. But A being negative doesn't tell us anything about A plus DI into A, which is fair enough.
Yeah, that's true. And like we can't have them all negative because then they'll become positive. And that's like not
like
bad.
The interesting point is when is the most optimal negative one, and unfortunately, I think it depends on what I and J are. I mean, okay, of course it depends on what I and J are. That's a foolish thing to assume it doesn't.
And bear in mind there are n squared terms to differentiate.
Yeah, but like they all follow the same pattern. Okay, so knowing that it depends on I and J should tell us it's not particularly optimal, because, well, like, it's also like not exactly continuous. The gradient doesn't change in my see that's okay.
Yeah, like because,
you
probably get multiple values of A for which like you get for which gradient is 0.
Like what we want is the sign change of the derivative, or like the sign changes of the derivative anyway. Not necessarily where equal. Wow. So, oh no, we could case bash the n squared possible values of A with n minus 1 squared possible values of A. Like, okay, so one of those values is going to be the absolute worst for A. Yeah.
Yes.
Oh joy. Of course, with that, we should be able to prove the n equals 3 case reasonably, right?
Yes.
Maybe not.
Yeah, sure, I can see that. I don't know, man, the n equals 3 case becomes quite easy.
Like...
It feels very telling that Pirates of the Caribbean is playing while we're doing this.
Oh, I'm loving it.
I was about to mention. Am I gonna get DMCA?
Sorry?
Am I gonna get copyright strike?
Playing the music?
Yeah.
Probably, if we don't speak loud enough.
Let's go! Well, copyright strike.
You probably should mute the button, never mind.
I'll just talk over it sufficiently loudly and hope that the music does not get picked up by the auto copyright strike.
To be fair though, that we still have multiple cases for the D3 because well D0 is 1. No wait, D1 is 0. Did we lose that? No, we didn't. It was just there all the whole time.
Actually, yeah, as a point, we've just like set. Yeah, we should have set D1 to be 0.
Yeah, I know. That's why I fixed it. Fine.
Yeah. So we want to find the A such that this is minimal. Again, yeah, but.
And we would have a good way of proving that, or like determining which one it is, the derivative. But also no. Wait, no, it's not even a good way. Okay, so derivative is a bad idea.
Yes, derivatives is always a bad idea.
Yeah.
Function isn't continuous, is it? But no, it is continuous. It's not differentiable.
So the optimal bad value is midway between two terms. Right?
Wait, if you consider the sums of every single one of them.
Wait, no, not midway between. Did we make an error writing something down? No, we didn't. But because the optimal value is midway between the terms, I just can't add up correctly. It's fine.
But like, if you could define the sequence, what a ij equal to di plus dj.
What?
Because I mean, yeah, that gives you like a ridiculous number of terms. But I suppose no, if it's not halfway in between, that doesn't work.
Okay, so the worst value of a sequence is when or there exists a ij such that, right? Okay, that's something that we've proved actually. Awful as it is.
Yeah, but you do realize all of these terms are positive, yes?
No. This isn't like x.
Okay.
So if it breaks, then it also breaks when you shift it so that one of the terms is minus the other one. And if it doesn't break then, that sequence of differences will never break for any term, but you have to check it at all the possible cases where that can occur.
Wait, hold on. If you've got
all half n minus 1 times.
If you have xi and xj, right, and add c onto both of them, then the absolute value of their difference will not change. But the absolute value of their sum will change by 2c, or might even flip.
Yes, exactly. That's the point, and that's why this thing works. That's why this substitution works, and that's why we can differentiate that substitution to get the worst possible value of any sequence d, any sequence d of differences, because you can have lots of different sequences of differences, right?
Yes.
The worst set of x's, the worst set of x's for any set of differences, is one where two of the x's, is where one of the x's is the mirror of the other. Yes?
Yes.
Okay. Does that imply, therefore, that we can induct? Because we could... Now we know that the worst the worst case will only happen if one is opposite to the other. So we can induct reducing by 2, where we can take out ones that are opposite, they're equal and opposite. Yeah?
No, but I get you.
The reason that taking out one was annoying was because, some of them were the same, and some of them were, opposite parity was annoying. But now we're taking out 2, and we know that they have to be opposite parity.
I guess so, but then, we have to do separate cases of n even and n odd. And,
do we?
And you don't even know that they are of opposite,
But, I mean, you say that, but haven't we done n equals 2 and n equals 3?
We haven't done n equals 3. We've said that n equals 3 should be easy.
Oh yeah, n equals 3 should be.
But but you have no idea over the. Wait, no, parity is whether it's odd or even.
Okay, I know. We keep using parity to mean sign, and it was really confusing for me before I had to give into it.
But we don't know how many elements there are that have parity A, and how many there are.
That's irrelevant. That's irrelevant because we're only comparing them with ones that have opposite parity, right?
Yeah,
but then eventually.
What Thomas is saying in the worst case scenario is going to be 2 of that equal and
opposite.
A,
because
minus A.
Yeah, because if you keep taking out ones with like opposite signs, then eventually you're going to get to something where they're all the same sign, and if they're all the same sign, it's fine. We're done.
Yeah. So we just do like x minus 1 minus the whole stuff, and xj minus the whole stuff, right? And also like the whole stuff minus xi, and the whole stuff minus xj. Which is completely equivalent to like xi minus whole stuff. Oh wow, I need to standardize my notation there. Where's the undo? Which is perfectly equivalent to xi minus the whole stuff, and minus xi minus the whole stuff. The whole stuff minus xi and the whole stuff plus xi subject to modulo values, right? Because xj is the opposite of xi. And then you want to compare that to adding everything. Which is xi plus the whole stuff. Like,
yeah, but you're taking everything in the square roots. You can't just like have xi take away everything.
Oh well, yeah. Like, okay, the dots imply like n terms or something.
Okay, yeah.
Oh, I should probably. Oh no, wait. I should probably treat xi minus xj in cases separately, because well, they occur, and otherwise I double counted them. And that's bad. Note that they'll just go to the square root of 2xi and root of 0.
Yeah.
But we're done.
Are we done?
Well, yeah, like, these two are the same. And they're the same as... Like, okay, that should be I. No, wait, they should be J. So it's not those two that are the same. No, oh, wow. Okay, I thought I would... No, like... Grr. That one is the same as that one.
Is it?
No, that's why I should have the ones over here. That one is the same as that one. And that one's also the same as that one. That one's the same as that one. And that one's also the same as that one. So therefore, adding a pair of opposite things... I also, like, did forget this. Plus 2 root square root xi minus xj. And those two are obviously the same as each other. So adding a pair of opposite things does nothing to change it whatsoever. Right?
Yeah. Okay.
But the optimal scenario, but the optimal bad is where two terms are the opposites of each other. But then we can remove that and get a smaller case. Boy. Which means all we need to do now is small cases.
We've done two. No, she needs to
no.
Well, we could make it. We could argue that it works. We could argue that it works for x1 and therefore it works for everything else.
Yeah, I'm gonna say it holds for x1. So.
Oh yeah, true.
Or like it holds for any set of n numbers that are all of the same sign. Therefore, you just keep keep adding on.
That's obviously true. As always, x1 is.
No.
Yeah.
You don't need to argue about holds. No. Arguing it holds for any set of all the same sign is awful, right?
No, it doesn't. It's fine because like you have big sums on the right hand side and you have like little differences on the left hand side.
Oh no! It's not. I mean, awful is in the sense of proving it. Like what we've done is say, you can sequentially remove. You can sequentially remove terms and alter the base, alter the base of this and alter the first term of this. You can sequentially remove opposing terms around 0. Okay, the order you do things. Wow. The first step is to move x1 to the worst position,
What do you mean by the worst position?
I.e., the one where the difference between the left-hand side and where the left-hand side, where the inequality is like as close as possible.
What's X1 again? Like just the first number in the sequence.
Yeah. Or like left-hand side plus t equals right-hand side. T is small. We know that can't be at infinities, so it can't be arbitrarily large because of your reasoning, what you just said. And then we've proven that happens when two terms are opposite. So we then go remove opposite.
Well, like
3 go to 1.
Well, basically, like all we really need to do is that, like, we've said that if they're all the same sign, it's fine. Then you've said that if we add any two terms of opposite sign, it's okay. Does that work?
No, Reese. We're not starting from they're all the same sign, it's okay. That's an awful place to start.
Well then,
I'm saying, given a set of values x1 to xn,
yes,
we can add arbitrary value to all the terms, and it doesn't change it. And like we can add an arbitrary value to all of the terms and treat them like okay.
Yes, because
inequality via
it won't change the difference, but it will change the it won't change the left hand side, but it will change the right hand side. So you can fix the left hand side, make the right hand side as small as possible.
Yes, and then the smallest possible thing happens when A is the average of two of them, which you could prove with calculus, or you could just say look. Saying look is easier. And then removing opposites actually doesn't do anything, so we can remove those terms and then repeat to reanalyze where the worst part is. We keep removing terms until we get to
people 1 or 2.
Yeah. Now, wait, do the terms have to be distinct? I want to check, like, do the terms have to be distinct
They
or
don't
something?
have to be distinct.
Okay, but if they are the same... Okay, well, if they are the same, then
the difference will be 0 and the sum will be not 0.
if
So
they
it's
are
like...
the same, then
can't
the
you
worst
make them,
case... The worst case
when
will
they're both 0.
Yeah. So, our thing doesn't break there. Like, it shouldn't have done, but it's good to check.
Okay.
Jesus Christ.
Alright, problem 2 down.
Problem 3 it is, I think. Probably.
Oh boy, the geo.
It's geometry time. I've put it over here.
Apologies to
That's
anyone
tiny.
who saw the first bit. I was just like, checking the relative lengths.
Okay. So,
angle conditions.
Okay, right. It's
No.
diagram time. Let's see. So we have...
Wait, where have you posted? Oh, you posted it over here. Okay.
Here we go. ABC.
Acute triangle with AB being bigger than.
Oh,
Yeah,
we
put
can
it-
zoom in on the diagram, so we don't have to
That's
do big
not
angles.
big, is it?
Yeah, I was no. Kieran, you've drawn. Read the length condition.
Yeah, I know. AB. Oh, AB's greater than AC.
I did dox you. I'm sorry.
How dare you?
Have you seen the name of the YouTube channel? Reese?
Yeah, literally, it's on the name of the YouTube channel recently. Yeah.
Oh, okay, never mind then.
I should probably have made that a bit bigger, shouldn't I? I'm just gonna have to zoom in now.
No, we can zoom in. It's fine.
I zoomed into 100% and now I cannot see anything. Okay, right, here we go.
Wait.
The point
C.
E on so like D
D
is going
relies
to
on the angle bisector.
Realising the angle
AB.
bisector. Okay, there you go.
Okay.
So there's D.
Is this DF of 51? Wait, no, it's interior point. Never mind, it doesn't work. A point E on the segment AC.
AC. That's why it's ADE and BCD.
So BCD is
it's gonna be
fixed.
about like there.
Yeah.
So those two angles are equal. Oh god, this triangle's gonna be gross.
With point-
And this diagram is going
the point-
to be gross.
The point F on the segment AB does basically the same on the other end.
Okay. So F's like there. And you have that angle.
And X is the point where,
That angle.
and then X is where
X
like
is the
X
point
is
CX
the point where the perpendicular
VX.
bisector meets
So
AB.
it's gonna be
Oh my goodness!
On the line AC, on the line AC, which means that, like, so it's continued beyond.
So it's like
yeah. Well, basically, yeah. I'll move.
Oh boy.
There are one known to be the circumstances of ADC and EXP. There's a right angle in there.
So circumstances of ADC.
Thomas, you're using like tool that's cheating.
That's
ADC
and EXP. Well, I'm going on the basis that I would be able to draw a circle.
EXP is gonna be like there.
I'm not going to use any fancy tools, but I am able to use a compass. Like, I fixed that when I was 15. That's not a flex, but... Yeah, is this acceptable then? Because, like, I'm pretty sure... Maybe like the arbitrary accuracy, so I should thicken the lines a load more. Wow.
Sorry, Griff.
Oh no! I'm just gonna get rid of it. I'm just gonna get rid of it. Like, probably is a better idea.
Prove that these three lines are all collinear, right?
They're concurrent.
Concurrent. That one.
Oh boy.
These three lines are all collinear. There we go. We did it, lads.
Oh boy.
Okay, this looks like it's gonna be fun.
Gonna be manky. Concurrency. Radical axes time.
Radical axes time. Are these gonna be cyclic? BCEF. Is BCEF cyclic?
Probably not.
Lovely stuff. I can tell we're gonna have a blast with this question already. Okay. I mean, we've got to find a way to interpret these angle conditions somehow, right? Like E and F, they probably aren't arbitrary, right? Like there's probably some...
I mean, like, it depends what happens if you vary D. Because, like...
I mean, yeah, of course they depend on the position of D.
Okay.
Can you use like alternate segment theorem anywhere? Like, as in through tangency things.
Are there any circles we have?
Okay, I'm just gonna zoom in a lot. Can we use different colors for the angles? I feel like
probably a good idea.
We can use colors.
We should probably redraw the diagram because we have a ruler. Is it like a straight line tool?
Okay, I think using a straight line function here is bad on the basis that we have like a lot of precision in how we can draw lines and circles on this.
Oh, but I do not.
And therefore, no, as in we can make them really thin.
Oh,
and
I see.
That describes things accurately. So therefore, we probably shouldn't.
Oh.
At least that's the logic that I just worked out just now. So there we go. Alternate segment theorem obviously doesn't work nicely.
No,
but that doesn't mean it doesn't work.
There are equal tangents, they're equal angles, but I don't think we can use anything. We can't use any tangency things.
Well, yeah, it wouldn't be any fun if we could use tangency things immediately. It's an IMO problem 3. Like, I've never solved a geo. Okay, I think I've solved one geo Q2 ever, let alone Q3.
I've never even solved an IMO Q2 or higher. I don't think, apart from like that weird one from 1997.
Laughs at solving 2019 GA after like 3 days of straight grinding.
Okay.
Yeah, I looked at one for 2 hours and didn't get it.
Okay, well we can
mourn the dedication.
We can mourn later.
Okay, well, what are the chances that inversion's going to be useful here somehow?
If you want to use inversion, we don't use inversion yet, because that seems...
Yeah, we definitely don't use inversion yet. I want to get some stuff about this diagram.
Yeah,
but,
and also like...
We've got to find some circles.
Yeah, I'm going to say, there's no point in inverting if you don't have any circles.
I mean, is it theoretically possible that you can just kill this radical axis, but the hard thing is going to be proven
Probably.
more cyclic?
Wait, invert about x with radius xb, then b and c remain fixed.
That's true.
But where everything else goes is anyone's guess.
Yeah, I mean, where everything else goes would just be like random.
A
You could
yeah.
theoretically you could invert about the in circle because
Wait, that's a midpoint. That is not a midpoint.
Oh, okay.
Oh well.
Yeah, artistic license for it.
I was really confused as to how you'd got this point M because I wasn't looking at the thing and. Oh.
Shush. I mean, yeah, the other option we could invert about the in circle, and like, because D and A obviously stay on the same line as the in circle, and like B and C get mapped to nice points. I don't know. I don't know where anything else would get mapped to.
Wait, ooh, isn't it also true that the that ADB and BFX are also concurrent at that point, right? No, it's not. No, it's not true.
No.
Because it would be Y, point Y, which is different.
Yeah.
Is it? Wait. Oh yeah, it could be point Y, which is.
Yeah, but that means
is drawing that useful? I don't think.
Probably. Because like if you can do stuff by symmetry or something.
Well, yeah, but you can do it by symmetry on comparing the EBX to the EX to the EDX, which is like cool. But not that awesome. Like, especially the circumcenter of FDY is going to be awkwardly inside the triangle.
Yeah. And the of ADB. I mean, like at a glance, it does look like it concurs. But remember how we had the AB greater than AC condition?
Yeah, I mean,
I just think that's that all the diagrams are the same. But
yeah,
that's who doesn't know Geo.
That's my thoughts as well.
Well, this is getting us lots of places. I suppose we should do DFF 51.
DFF 51 doesn't really work, does it?
Why not? XM and G are like. Oh, I keep doing that. XM and G are linear.
Wait, GB.
Yeah.
Well, L is the classic name for it.
It's T, isn't it?
No, it's L.
I've always used T.
Oh, I see. You're doing the circle. Nailed it.
Okay.
I will draw in the circle. No, it's not. Whatever.
Oh, first already drawing it. Okay.
So what happens if you invert about L?
Oh, bad things.
What happens if you look at the intersection of the circumcircle of DBC and AL?
It's D.
And L, probably. Oh no, the other one. Never mind. That's gonna be a weird point. I don't see how that's gonna be relevant.
Because D is arbitrary, it doesn't look like a fun thing. Hold on.
But look at those angles.
Yeah, I was gonna say, it's like BKC. Is that similar to DEF?
I mean, if it is, it feels like we're losing a little bit of information, but that's not that bad, I suppose.
I mean, I suppose like you have to get angles in.
Because then we could then reflect it over that line. Which, even though it doesn't seem like it, does pass through the circle center.
Yes.
Which is Q.
What if L is the circumcenter of that? No, because that was the excenter. Not necessarily.
Yeah.
Oh, yes, necessarily.
And that's cool because it means that those reflected lines still do pass through L. But then we no longer have... No. Those not those reflected lines pass through L. Of course they don't. Why was I reflecting it in the first place? I was reflecting it in the first place because I wanted those angles to be nicely done.
Why are you reflecting? And what are you reflecting?
I wanted to... Okay, find the point at, J on this circle, such that angle...
that CBK equals DJC. Wait, but if CBK equals DJC, doesn't that mean that?
Wait, they're on the circle. Since it's on the circle, that's bad. What I'm
I was going to say that won't that only work if CK and DC
Yeah. I was wrong. It's fine.
The same arc lengths.
I was wrong. It's fine. Okay, so the next step is to ask, what do you get if you take the symmetric thing of KD in KBC? Is it a Symedian? No.
No.
Actually, why is it not a Symedian?
Which bit again now?
Why is KD not a Symedian of KBC?
Because... I mean, it depends what the angle.
To be fair, you could say why is it a Symedian? That also works.
Yeah, I feel like you just kind of looked at something that kind of looks like a Symedian. It's like, yeah,
No, hold on, because you have to claim that the wait, no, it can't be a Symedian because it has to intersect the perpendicular bisector of BC outside the triangle, and it doesn't. Because obviously, because the Symedian point opposite K must lie in the perpendicular bisector of BC, and based on our diagram, because AB is bigger than BC, then it doesn't work. I think. You get that?
What?
Because obviously, if you've got a Symedian, right?
Yeah.
Do that again. Do that again.
Go on a different drawing tool.
Yeah, I mean, if you've obviously got a Symedian, then this point here, P, is on the perpendicular bisector of BC, right?
It's on the what bisector?
It's on the it's on the perpendicular bisector of BC, yes.
No.
Because it's the intersection of the tangents, right?
Yes.
Which means PB equals PC by tangent secant.
Wait,
yes?
Why have I never seen that before?
What?
Why have I never thought of that before? Nice.
Which means that if AD is a Symedian, it must insert the perpendicular bisector of BC at some point outside the triangle, but obviously it intersects the perpendicular bisector of BCL.
Okay, let's now ignore all those wonderful reasons and construct the tangents to DBC anyway.
And find where they intersect. Well, they have to intersect on the line XM.
What?
Don't they?
Not with this diagram, they don't.
Oh, wait, tangents to ABC?
No,
Or
DBC. So they still have to intersect on the line BM, because that's just sensible.
Yeah,
Yes.
because perpendicular bisect shenanigans. You've just drawn your diagram terribly.
Yeah, this diagram's pretty rubbish.
Yeah, okay. So, Kieran,
no.
would you mind drawing a better one?
What happens
I'll
if Thomas
try
uses
my
the wrong
best.
circle?
I will try my best.
What do you say?
Going to try and... I'm going to try and draw the diagram, and paper later. I can't find my ruler.
Okay, I probably shouldn't use red. We're already using red for angles.
Oh, damn, I did it already.
Yeah, the reason that's cool is that we manufacture other, we get that angle again. Right?
Because of alternate segment? No, because... Yes, no. No, it doesn't, because you'd get the whole... Well, do you? No, you wouldn't. Yes, you would. No, you wouldn't.
You get the angle again.
Oh, yeah, you would. My bad.
Okay, you get the... Okay, that's something for definite. You do get the angle again.
Yes. So we have multiple triangles that are like, haha, we have this angle.
Yes, that's not that cool, is it though? Since X doesn't depend on D at all, so it's too much to expect anything nice there.
Yeah, X is... D is arbitrary and X is fixed.
So if we want to find some nice triangle that's similar to DEF for whatever reason, or oppositely similar to DEF for whatever reason, we have to construct it ourselves. Also, Daniel...
Yeah?
Are you telling me that the chat is dead?
Yes. There was a high Selwyn. That's it.
Yeah, the chat's quite dead.
On the YouTube.
On both YouTube and Discord.
I mean, the Discord was last used 15 minutes ago, so you never know. It's not that dead.
Okay. Anyway, back to thinky time.
I have made another diagram for you guys to decimate.
I knew you'd do that, Fred.
Excellent. Yeah, back to thinky time. Intersections there and
why are you drawing in tangents again? I feel like we're losing track of what we're actually trying to prove.
This thing.
Yeah, I know, but I feel like why are we drawing in tangents and things?
Because DEF isn't, because EF is an awful line, and I know that O1, O2 looks far more awful, but I want to figure out if I can find a triangle that is similar or oppositely similar to EF, because then we should be able to do something cool with angles.
Right.
I want to try and draw an actual scale diagram on pencil and paper, because might
do that.
Some more insight.
Then do that.
Yeah, I'm gonna try and do it. I need tables.
Would do that, but I would do that, but I literally haven't used my ruler or compass since the TSTs. Actually, that was licensed as a step.
Just do it, mate.
Wait, what's that thing about triangles being in perspective?
You mean, wait, what do you mean by perspective?
That's if all the corners touch the thing. Blah blah the words. The corners are all thingy. Words are failing me.
I'm pretty sure it's corresponding lines joining corresponding corners. This is concurrent.
Yeah, that.
Yes.
But what's the other one?
So
the other one, being in perspective from a line, is like when the sides meet at points. Is like Pascal's theorem, basically.
Okay. So what? But that's like all that's doing is saying that like the 630 line are conic, right?
No. The conclusion is basically Pascal's theorem. Not anything else. So what that means for this is if we could prove that O2F, O and O1E intersect on the same line that.
So we can show that like O2BF and O1EC are in perspective.
So that's also the same thing, I think.
Then FO2 intersects O. If O1C intersects O2B, where do they intersect each other?
On an A-Shavian.
Oh, on an A-Shavian. Then F2 intersects FO2 intersects O1E on the same Shavian.
So if they both intersect on an A-Shavian, then
okay.
I think they'll go through. And the triangle has to be similar though, which is awkward, but they do look similar. Do they? Yeah. To be fair, with our diagram, that might be more of a thing they're not similar than they are.
I mean, O1 and O2 are very
Wait, O2 is the circumcenter of EXD. It's got nothing to do with the
So O2.
Yeah, O2 has nothing to do with B. Apart from the very, very large quantity of stuff that it has to do with it.
Hold on. What can we say the radical axes of ADC and EXD are? Because then we can get that as perpendicular to a 102. Like, obviously D lies on it. What would be another,
Well, EXD is not that glorious.
It looks like like O102, that looks perpendicular to AD, so I might guess that A lies on EXD. Is that something that we probably shouldn't prove because it's stupid? Wait, no, 3 of them are collinear, never mind. That was silly.
You realised it was silly in a short space of time, so all is good.
Shut up, Fred.
Maybe
Sorry.
Maybe the line MD something? No. Maybe the line MD or DM is the radical axis somehow.
Oh, then that does not look.
Well, it doesn't. But look where M is.
On the perpendicular of BC. Perpendicular to BC.
No, look where M is on our diagram. That doesn't look accurate either.
No, that's true. At what point do we resort to GeoGebra?
We have hours to go, Reese.
Not for a while, because we have just under 3 hours left.
Oh no, Geo. To be fair, I'm already halfway through my chocolates as well. So this is not.
There was no garlic bread I haven't eaten. Still got an Easter egg that I haven't eaten yet.
Eat it.
That's gonna go off, mate.
No, it doesn't go off. I once had Easter eggs left over at the next Easter. It's fine.
Yeah, no, same with me.
Yeah, okay, I've drawn a scale diagram and it's gone very wrong.
It's
Clearly it was not very
scale. It's very hard to draw scale diagrams.
No, Dylan, use colours. Colours for angles, please.
Use what?
Colours for angles.
I don't have colours. Oh, is it on the whiteboard?
Yeah.
Oh yeah, sure. I mean, I haven't really done that up till now. Hold on, my intersection of EF and BC and O102 and BC are quite literally 3.5 centimeters apart. It could not be further apart if I tried.
Okay.
So clearly I have mucked up the scale diagram. ever so slightly. But you know what? When you fail, you try again. You try again.
We have lots of time to prove that.
Yeah, I mean, I also have lots of time to draw a good scale diagram, so I will.
Yeah, that's a good point. We can get better at this.
We can get better at drawing scale diagrams. It is fun.
And problems have whack angle conditions like the one we have here. It's very
I'm loving this because it feels like you have to be inventive, and I'm okay at being inventive sometimes. Like the line parallel to BC through D seems interesting, but then you don't really get anywhere.
Why does that seem interesting?
Well, because then you get more angles around D that have the yellow and red angles, but then you just sort of get these things reflect nicely or are the same, and that's just not so cool. Like, in triangle ADB, the line through D parallel to BC is isogonal to DF. Which sounds great, but I really don't know how you use isogonal things.
It's also isogonal to DE in relation to ADC.
Yeah, which sounds great, but I don't know how to use isogonal things, so maybe not.
No. My knowledge of isogonal conjugacy is that O and H are isogonal conjugates of each other, and I is its own isogonal conjugate.
To be fair, no.
Okay.
I mean, this was a good start. I did enjoy problem 2.
I didn't.
I don't know. I like doing stuff like that. That's fun.
Monkey algebra.
It wasn't manky. You got to mess around, look at where it's got lowest minimal values and cool ways to reduce. That was cool.
It was manky.
Right. I think it's a good IMO problem. It's just phrased really badly in the question, though I can't think of any better way of phrasing it.
It's.
It doesn't look nice, but it is nice.
Anyway, probably back to
it's not it's not a functional equation, and so therefore it's nice.
Functional equations are better than that, mank.
Nope.
Anyway, back to geometry. Okay, what can we
does a
try?
triangle similar to DEF with a D at B look like?
Good question. Not one that I'm willing to answer because I have no idea.
Well, if I say it's got one of the sides is BC, does that even help?
If DF is BC, then we get.
If DF is BC, then BD is DA. So
why does that work again?
It just does. Angles.
Thanks.
So we find the point there, such that that angle condition holds true. So maybe we don't want the point where BC is one side length. Instead, we want the point where somehow there's a circle that works nicely. Because BL is cool. So if we take this point, call it like V or something.
Which point? Oh, we're on two diagrams.
Point V. So where AD meets BC.
Angle bisector theorem.
Oh, sure, we can use that thing if you really want to. Then we know that the circumcircle of AVB, the intersection point of that with DB, is the corresponding point. Is the corresponding point. Okay, we know that BVX is similar to DFA.
Don't use X, I've already used X.
BVY?
Sure. Why is this?
Okay, well, the angles at B are obvious, yes?
Wait, BV, yeah, that's what we've got a yellow one there.
And angles at Y are obvious. Like,
what
we
circle
literally
is this?
defined Y is on the circumcircle of AVB.
Okay, so there's, yeah, okay. So we've got the angle at A, which is the same as that one. Yeah, okay, yeah, that's fine. Got that. But you're adding in points for the sake of adding in points, I think.
No, I'm adding in points for the sake of adding in points, but it's not that disgusting a point, that's the thing. The issue is that I don't know, or I can't think of a nice way to translate that into getting, like, the other corresponding point in that BVY. Because it should just be, like,
also, I'm pretty sure you're going a bit off topic here, and, like, we need to get to, like, this thing.
That's a good point, but I don't see a way of getting to that thing without finding some cool angle things. Like, I don't know how I'd prove it anyway, so I'm hoping to find other stuff about the diagram until I get to a point where I just understand the diagram well enough that it seems natural, and then maybe I can look from there. Yeah, like, at the moment, I don't see an action plan for solving this problem, which obviously isn't quite optimal. But, yeah. Also, on that note, I'm gonna go to the toilet, so
Okay.
2 minutes, I guess.
Right. Yeah, this question is horrible. I'm not very good at thinking out loud. Anyone else there? Have you both gone?
Yeah, hello, I'm here.
I'm still here.
I'm just trying to think about it. Like, I'm trying to still construct a good scale diagram. I drew another one that was also rubbish.
Yeah, it's like it's a bad problem because you can't do an accurate diagram.
At least it's hard to. I still think there's something to be said about considering some concyclicities here.
Yeah, like B, C, E, F cyclic potentially.
Yeah, I mean that's what I.
Hold on, but like that would mean that EF has to be parallel with the feet of the altitudes.
Is this one not head solve for you guys?
What's up?
Actually go away. I will not take this toxicity in this lifestyle. We are respectful people. Oh boy, very accurate song here.
I mean, like, is FE parallel to the line during the altitudes? Like, I mean that's like.
I don't know.
If that works, we could get some cyclicity thing going on. Like 01 and 02 seem completely sort of random.
Can you also theoretically prove? Wait.
Like, what is there to do?
Yeah, I agree. There's not really a lot to do here.
Alright, I'm back.
What are those?
I'm back. I'm too. Wait, sorry, what was that?
What are those blue lines? Or
Tangents to the
Tangents.
circle, BCD.
oh, okay.
There isn't a triple concurrency between A, D, E, F, and C. But
Oh yeah,
it looks like it.
yeah, that's definitely coincidence.
Oh. Found my head on a silver blade.
Right, yeah, we need...
Glad is singing.
So we were thinking, like, can we show BCEF cyclic? What's that point here that you just drawn in?
I was just making the thing, making BVY bigger.
Your GeoGebra is basically the same as trying to draw it on an electronic even like you can't even GeoGebra it because like angles are manky.
No, you could Okay, Reese. Next thing is to figure out how you would GeoGebra it.
Yeah.
Because if you can figure out a way of GeoGebraing it, then fun. Actually, I think the way you would GeoGebra it is by doing that.
It's by just like moving the points until you get something that looks good.
No. By constructing Y, and then what would you do after you constructed Y? Right? Because you can construct Y just nicely, just from A, B, and D.
So by getting then, like, to get the BVY is similar to DFA.
Yes, that's why the thing here is.
I've proved BCF is cyclic.
Oh, how?
So you take the K proof constructed before. You get AFD is similar to ACK.
Yes.
Two angles of the
Yeah.
Yes.
And then similarly, AED is similar to AB.
Oh! And then just bash PowerPoint.
Yeah.
Because, wait 1 second, so you've got that, what, AC over AP.
AD over AP is AF over AC, then it's also to AE over AB.
Yeah, okay.
So AF times
Wait, no,
AE
can you write that down, please? I'd like to.
I'll do it.
Oh, hold on, I solved it.
Alright. So, okay, so that's something fun. So now we bring 0102 into play.
Okay, progress. You win these.
Yeah, that's very cool. Wait, P?
Yeah, it's K. P is K.
Sorry, I had it as P on my diagram.
Yeah, we have a different P.
My bad.
A random P that we just put in.
That P is really
Where's
weird.
your P?
CP is parallel to AD.
Why?
Thomas drew it and I was like, sure, call that AD.
Because BCZ is similar to
so
similar to,
why would you give P to such an arbitrary point?
I don't know, it wasn't used up. Okay, but we have a cyclic thing. That's good.
That does suggest that the other bit is trying to prove that the other things are also cyclic.
Yes. But now 01 and 02 present some problems. Because what are they again?
Circumcenters of EDX and ADC.
Yeah. So.
Oh wait, I actually remembered them correctly.
I'll write this here just so I can remember them. Oh wait, I didn't mean to write EDL. I'm not in EDL, don't worry.
Wait. Why have we got a timer that's counting down?
That's the time of how long we've had, like that's not how long we got left. That's how long we got left plus 90 minutes, because the time only works in intervals of 100 minutes. So I just did it in three lots of 90.
Oh, okay.
But we've got just under 2 hours left. No, 2.5 hours. Not even halfway there. And I suppose like most of the stuff doing stuff in the IMO will be writing up solutions.
Certainly most of what you should be doing in the IOL. That was fun.
Oh, my dogs are barking.
You can hear them.
Yeah, I could barely hear them.
Hold on. No, someone's stealing them. This way.
Well, okay, if we wanted to prove that 0102 was like cyclic with something, how would we be best to prove that?
Yeah.
Because I'm going to repeat exactly what I said earlier. B does not seem to go well with 01. Or really with 02.
Do these 2 points intersect on AD? Do O2F and O1E intersect on AD? Probably not.
What was that?
Motorbike, I'm assuming.
Yeah,
Oh, wow.
motorbike in the background.
Right. Okay. We're getting off topic. Let's do this.
No, wait. Oh, no, it's fine.
I don't know if it's useful, but I've got some angles are equal.
What angles?
I've got this angle here, to this angle here. And
That means you've got some. Yeah, that means you've got some of the
side.
triangles.
So on the other side as well.
DVC is similar to DE, intersection of AD and EF.
What was that, sorry?
I
get
yeah.
it.
Okay, cool. No, we've already got a Z.
Where's the Z?
We're running out.
No. Do call it a Z. I'll delete it and get the less equal Z.
I should really write down how I got that, shouldn't I?
Yeah.
Yeah.
FED equals AE minus AEF, and then the AED was equal to ABP by the sum of triangles, and then AEF the ABC. But I thought you named it K. Let's say K. And that's equal to brain fart K ABC, which is equal to KBC. Oh yeah, it's also equal to this.
Yeah, so we've got lots of similar triangles.
I'm gonna really quickly grab a snack because I'm starving. So, be right back.
Alright. Eat your snack.
Okay.
I'll just check the angle thing. Oh, and that angle thing worked because of cyclicity stuff. Ah, woo.
Yeah.
I'm just a fool. Okay, but I'm not sure. I mean, it probably is useful. I'm just not sure how useful in the face of the next glory. Okay, that's actually quite big progress. Well, it feels like it's quite good progress. It might be completely useless.
No perseverance. You see an EXT. Notice how the circles into 01 and 02 both pass through 2 points on the line AC and then D.
What?
As in, the circles into 01 and 02, look, they pass through...
Yeah, okay. Okay.
So that might be something fun. Well, there's the radical axes of them, and it doesn't look like that's pointed any use. Unless it's on the circles of the BBC. Which I very much doubt.
I likewise doubt. But we should do something with it.
Then we've got a line parallel to 0102, which we can probably show that like
Hello.
EF is so that like lines are anti-perpendicular to each other or something.
Hello.
I'm back.
What? Anti-perpendicular?
Wait, you know what anti-parallel means, right?
I do.
So just like a line that's like like two lines are perpendicular two lines are anti-perpendicular if one line is perpendicular to the line anti-parallel to the other one.
Oh goodness, that's amazing.
I just made that up on the spot, but
With respect to a point.
Well, that's amusing, I guess. I mean, so the next step is prove they're anti-perpendicular with respect to the points, the intersection of FO2 and EO1. Such joy. Yeah. No, that's fine. We'd have to prove they intersect nicely first.
yeah. But like, from what I've wait, has anyone got like a nicely drawn diagram?
And the crowd goes silent.
Because like 02F and 01E looks like the intersection AD. So, do they?
Thank you. I'm turning the bar up.
Wait, hold on. I just realised something. Since BCEF is cyclic, that makes EF parallel to the B of the perpendiculars we see in B. Doesn't that then make an inversion of B really, really good? Because it makes BCEF an isosceles trapezium, right?
Wait, EF is parallel to what?
To the perpendiculars. EF is perpendicular to the traditional EF.
If you invert D, that makes BCEF an isosceles trapezium, right? That might be
okay, I think inverting the D is very nice, but not with respect to circumstances.
Surely you know about M, because like you can then fix BC like E prime and F prime.
There will find me.
No, I suppose F and E then do manky things. Because it's a circle, because it's a circle not passing. No, yeah, just match to the circle then. But I guess you can invert. Surely inverting about C would be better because like C's more sort of like in the diagram.
Yes, C is annoyingly more in the diagram than E is.
Because you've got the circle ADC passing through it. Wait, surely inverting about D might be helpful.
That was the question.
Because you got two circles passing through D. Although what happens to a circle inversion?
Not great things. Like severely not great things.
Sorry, what was that?
Not great things unless you pick a nice radius.
A radius that keeps one of E, X, A, or C fixed. None of which is obviously the same as.
No, we don't care about radius other than making it for the same kind of thing.
Wait, can we use moving points?
If you remember how to use moving points, feel free.
I don't know how to use moving points.
Well, I don't know sufficiently on weird problems.
But as D varies along the angle bisector, E and F also move continuously. X is fixed, so O and O2 move continuously.
But I can't remember how many degrees of freedom that counts as when you have weird intersections of stuff, and I think it gets quite big.
Okay, never mind then.
Okay, just so AED is the same as angle ABK. Is there any nicer characterization of that?
ABD equals ABK equals. Wait,
well,
what's this?
If we let that point be W.
Okay, can we have another diagram? Migrate to the second diagram.
Okay, migrate to the second diagram, because the second diagram focuses more on O1 and O2. Yeah?
Yes.
Because we already know that BCEF cycle. Thanks, Kira.
What was that?
Just saying thank you again for BCEF cycle.
Oh, no problem.
BCEF cycle feels like, I don't know, IMO P1 or something. I still couldn't solve it, but
Is it? It wasn't that bad.
I mean, I suppose you have to.
Similar triangle.
Yeah, it was similar triangles after you construct K, so maybe BMO2.
I had K given to me though. So.
Oh, you did, to be fair. Maybe, yeah. That's a good point. Maybe BMO2 P1 or something, P2 or something then. But I don't think constructing K is that, unexpected. At least, it was something that I thought of without that much thought.
Constructing K is not the only way to show BCEF cyclic as well.
Ooh, ominous.
I imagine there's a lot of ways of doing it.
Ominous and thank you.
There's probably another way that yields more information now, isn't there?
Yeah.
Yeah. Inverted D straight away to prove it.
Oh, brilliant.
Wait, actually... I mean, okay, if you invert a D immediately...
Then what does that do to, like, you get that A and C map to a line passing through D, and E and X map to another line passing through D. But all the action seems to be going on the line AC. Wait, do X, A, E, C form a harmonic range?
X, A, E, C. I don't... Oh, I mean, I want it to, but I don't think there's a nice way of proving that. I wish there was a nice projective solution. Projective solutions are always the nicest.
They're a bit bruh. And that's because I don't have to do them.
They are a bit bruh. So, anyone interested in coordinate bashing?
No, not doing that.
There are some right angles, I guess.
There's one right angle.
Did I just forget what happens to a line under inversion? Yes, I did.
Nice one.
Did you just try and invert?
Oh no, I know. I'm still trying to invert.
Oh god.
No.
That's a big
I forgot what happened to. I forgot what happened to a line. That's why it took me so long. I also didn't change any of the lengths or any of the angles, but that's okay. I'm really liking this playlist.
I meant to only put the third movement on it, and I think the bot's changed the whole thing. So, to keep it the 4.5 hours, I've asked for it to be skipped.
Bruh.
Oh, this is good though. We should have played this as the starting music.
Yeah. Maybe.
Why have you drawn circle? Oh, because you inverted about D.
Indeed, I did.
So you basically want to show now that the circumcircles of FED, BD, C, and O1
Wait,
O2
so
share a common point.
for anyone who's watching this who might not be familiar with inversion, which, I mean, yes, inversion is a weird transformation of the diagram that you can do, and the main property that I'm using here is that angle ABC goes to angle AC dash B dash if you invert it A.
So
here,
I don't remember.
I inverted it D, and therefore I get all these angle things.
Okay, that probably work. You probably can invert then about D, because then not only do we invert. What happened to circumstances post inversion?
nothing nice. I probably would do that with angles, just because I can't think of anything better to do. Unfortunately, this gives me something really annoying. Like, it would go to isosceles trapezium, it just doesn't solve nicely.
Well,
yeah.
Because now you invert it, if you could take it to the second intersection of the line, like, of the circles FBD and DEC, if you show that, like, D, we'll call it...
The second intersection of the circles FBD and DEC. Oh, you mean the second intersection of the actual circles?
Wait. No, of the both inverted circles. Call that Q. All we do is show that DQ, O1 prime, O2 prime are cyclic.
Wait, I'm not going...
Because,
guys, really quickly, I'm not going crazy. I swear it's a thing, because I think I've just done something. I swear it's a thing that, like, if I use the context of the angles in the diagram I've got, I'm going to move across to my cleaner diagram. Is it true that if these two angles add up to this angle, then the two circles are FED and VDC are tangent? I'm pretty sure that's a thing, because if so, then I prove they're tangent.
Then
yes, they are.
Post-inversion.
Yes, they are.
Post-inversion, the lines are parallel.
Because you can draw the line. Hey, you know the line I said ages ago we should draw through D parallel to BC?
Yeah, I mean, because I've just done that.
No, that's not tangent to them.
That is.
I've done.
No, it's not, because we're looking at.
No, the line through D parallel to BC
is tangent to what?
So I got
is not
FED plus D BC
is not tangent. That's not the line I was thinking of. Wow.
Line AD maybe?
Yeah, it's just anti-parallel.
Which is the line of parallel to FE.
Is equal to what did you call it? K BC, or what did you call the point where it touches BC? I forgot what you called that point because I called it K. But
do you mean DBC, or do you mean BCD?
DCB, sorry.
Okay.
Words are hard. And that's equal to, what did you call the point? I've got it different on my diagram, so you called it V.
V, okay, yeah.
So equals VDC plus reach your mouse away. Plus DCB, which equals DVB. But then also that's equal to 180 minus DKC, which is equal to 180
DKC
minus
wait,
KDB plus not K, you call it V.
Yeah.
I need to change it there as well.
180 minus D.
So
okay.
So DDB plus VBD. But then VBD is
VQB? What are you using for
ADF.
Q? What are you using for Q?
Q, that's a D. Sorry, that's a D that got intersected with a B.
Okay, sure. I'm also really impressed by how you've managed to... Okay, I don't, like... There to there is plausible. It's fine, it's all good.
Yeah, I went backwards. So, then that is equal to FDA. That's 180 minus VDB minus FDA.
Yeah.
That is equal to FDB.
Pog.
FD. Yeah, because ADB is a straight line. And then...
Okay, that's cool.
That's
so, not only... So not only are FEBC cyclic, also FEB is tangent. Those two circles are tangent at D, and that line D, that line tangent to both of them through D passes through the currency point. Never mind, probably it does. So all we need to do is prove that the circle D0102 is tangent to that line at D.
Oh my god, yeah.
Yes.
Progress! Fucking progress!
But it's still like, you know.
Reese, stop complaining. This is really, really good.
I know, it's good.
Maybe.
It's still having to bring 0102 into play.
Yes, yeah, but it's bringing 0102 into play with respect to D. Like, come on, D is on the circle that define them. This calls for
trying to think something. Wait, let me read this again. FED plus DCB is equal to V. I'll extend this to define it again. So I'm not reading. Oh, that shouldn't do that. We haven't used X at all, right?
No. But it's not relevant.
VDC plus DCB. FED plus D. Why are they the same again?
Why are what the same?
Why
because
are
they're yellow. Because they're yellow.
FED and VDC? Are they yellow in the old one? Yeah, sure. Yeah, okay. Plus DCB, yeah, is equal to DVB. Yeah. 180 minus VDB. Yeah, okay, I get that, I think.
Okay.
Okay. So
like tremendously pog.
Yeah. Wait. So the tangible passes through them because of power of point, right?
Yeah.
Yeah.
I mean, I didn't even think PowerPoint. I just went, let the two things go to a small distance, and it works. But yes, PowerPoint is the better reason.
So now it's. So what happens? If you invert about D, then we want to show that 0102.
That means you want to show that line 0102 is parallel to that line going through D after inversion.
Yeah, because the point there where they meet is the point of infinity. But
I don't think O is any nice. Okay.
No, like
maybe O isn't that. Maybe O isn't that awful of a point. And the reason I'm saying maybe O isn't that awful of a point is because, going back to a weird inverted diagram.
Yeah.
That's also green angle going to O, right?
Where's that
angle at center? Circle center is double angle at the circumference.
Sure.
And
wait, what they? Oh yeah, that could work because if you draw in.
Yeah, and then O1 is somewhere on that line. And it's sufficiently somewhere on that line such that the angle DAO1
what's it? EDX and
it's twice DCA.
Yes.
The original CA.
So then you have to work out what A0102 like.
And that's still green. Yeah, but Kieran is a legend at doing angle things that everyone really should be doing in Geometry Problems. But Kieran's a legend at it.
Great, I agree.
I just like badly angle chase and come up with nothing.
Yeah, I mean, I haven't even really tried to angle hit anything yet, though, and Kieran has just used skills, so this is epic. Other than that, obviously, it's just the same. It's just 2 angle DBA original. What we want to prove is that the lines. So we'll take anything of proving O1, O2 cyclic with BC. That would be cool.
O102 cyclic with FE would also work. Would it work? Yeah, because then if you get the radical axes of like O1 FE, because you've got more circles in there that we can do, right?
Yeah. I'm not sure what result you'd be able to use for that though. The line through D still makes the same angles that it does with DF and stuff.
Yeah.
What those angles are precisely is still slightly up for debate. I'll draw it in a different colour if it's important. Actually, no. I'll draw those angles in purple to keep it consistent because that is the thing. Yeah, so all you want to do is prove that O102 is parallel to BC and DF in this inverted diagram.
What?
Does this inverted diagram include all the information?
Probably not.
No, because O2 is not that point. O2 is not that point at all. At all.
Inverting about D means that AC maps to a straight line.
There we go. O2 is not the same thing as O1 with respect to the other bit.
Where does O2 go upon inversion?
That's what I'm working out. Sure.
I imagine it doesn't go to a nice point, surely.
No, it probably just like goes to.
Well, yeah, we don't even know any nice angles, really.
No, like you just know it. Like
we know that DO2. We know that DXO2 is twice DEC. Or no, is. Yeah, we know that DXO2 is twice angle DEC. Right?
Do we? DXO2
in the inverted diagram.
Oh, in the inverted diagram.
So it's twice original DEC. Yeah, so okay, we know that DXO2, I think.
Why does that work?
Is to green. Because DXO2 so inverted DXO2 equals normal DO2x, which is like
DO2x. That's
twice angle CED.
No, it's twice angle. Like it's twice angle DEX if you use directed angles.
And we don't use directed angles because it's at a acute angle triangle.
We still need to use directed angle. Oh
okay,
yeah, yes. Yes, got that. Yes.
The difficulty is when you put X on the diagram.
X inverts to a point like like all X, yeah, it doesn't preserve like with X to bicep DC, but it doesn't do that anymore. You getting anywhere?
No.
No, I'm not getting anywhere. I'm Thomas.
Shut up.
Well, we know that XAC are collinear. So X lies on the circle DAC.
Oh yeah, X lies on the circle DAC. It also lies on what else does it lie on?
MX, the circle MXD, where M is something.
Yeah, but that doesn't.
Okay, no. We know it. Okay, we know it lies in the circle ADC, and we know. No, we don't.
Lies in the circle ADC. Yeah. So like, wait. X maps this to some point on the circle AEC, and it also.
And the other property of it being midway between B and C, we need to add in somehow.
It also like lies on the line AB, which means it also lies in the circle ABD.
No. It also lies on the line LX.
Wait.
It doesn't lie on the line AB. You're being a fool.
Oh no, it doesn't. Never mind. Yeah.
But it does lie on the line LX.
Yeah, but then where do L and M invert to post?
Okay, no, L inverts nicely
because it
on the line BA, and also like, okay, when I say L inverts nicely, wrong color.
It inverts. It inverts to
there.
No. Wait, no, AB. Yeah, and it also stays. Yeah, it inverts to the point where the line AD meets the circle ABC.
Wait, no, that's not L. That's really not L. That's K.
Wait, yeah, no. It lies on the line AD. It also lies on the circle ABC because inverting about D doesn't change the circle ABC.
Yeah.
So again, it's where the line AD meets the circle ABC. M, on the other hand, M's a bit tricky.
Yes.
Midpoint to affine
We
transformations.
could try and identify the median and go from there.
We're not doing the median.
Well, what does the point at infinity on the line BC invert to?
Infinity on the line. What?
Well, BC and M and the point at infinity on the line BC is a harmonic ratio, and inversion preserves harmonic ratios. So what does the point of infinity on the line BC invert to?
E.
Shut up.
Well, doesn't it? Doesn't it? I'm genuinely asking.
I think I'm sure it does.
I don't know too much projective, so.
So does that mean that we want the point on the circle DBC that makes it a harmonic ratio?
You do that?
I can't remember how harmonic collaterals work.
I don't really know what they are.
Ugh. I stopped doing this months ago.
Like, the only thing I have about geometry is Tom Hilmer's lecture.
No, from what I remember, harmonic collaterals are pretty much just a median. But that seems weird because it's not a median. It's like an actual. No, does it make sense that the median would invert this median?
Probably. I don't know. The median depends what you invert.
Like, with respect to one of the vertices of the triangle, does it make sense that the median would invert this median?
So you look like you invert about A and B stays constant. C maps to who does C map to? Point C prime such that AB is tangent to the point BCC prime. And then yeah, I can't visualize that.
Okay, because if we can do that, then that seems nice. I mean, if all else fails, you could try inverting around A such that E and F go to B and C, and just seeing what shenanigans happen.
Yeah, but then like that kills like other stuff.
I said seeing what shenanigans happen, not solving it.
I'm gonna go for a walk and get some air.
Okay, see you. Take a dog with you.
I'll see you in like 2 minutes.
Make it 5 or something. Sitting down and doing math for X hours isn't that healthy. And you were sat down before this, although you've probably already gone, so you can't hear me. Okay, quick, while he's gone, time to solve the problem.
Let's go!
I can't think of anything. Is it nice if we prove the Semedian thing? Is it even nice though?
I don't know. I do not know. I'm just trying to bash some, I'm literally trying to bash some stuff. I'm so tempted to stick it into GeoGebra.
I think it would be because angles. Like, okay, if we prove this a median thing, I think it just becomes an angle chase, and you were god at angle chasing. Because I think all the conditions would be included in a diagram that just included circles and stuff.
Yeah, maybe. If it was just angle chasing, I'd be happy with that.
So now, I have to try and prove a fact that is either just well-known and quotable, or isn't true at all.
Lovely.
We love. We heart.
We stand.
Yeah. Wait, of course it's not true. Oh no, with respect to the new triangle. That's why it was a debate. Okay, it looks like it. Wait, is Reese? I guess Reese isn't streaming it right now, so I probably should.
Oh, I'm still streaming on YouTube.
Yeah. But for the sake of people who aren't watching it on YouTube or something. Right, there we go. You get to see this terrible, terrible diagram. Yeah. That's a straight line. Kieran, what are famous angles around the median point?
Oh, Jesus Christ. I'll be honest, I do not know.
It's fine, we'll just derive them.
As you do.
I mean, that's my approach to all of geometry, so... I mean, I can't even figure out how exactly I'm going to prove what I'm supposed to prove, but it will be fine. Actually, if I could just prove that they're similar, wouldn't that work? So, a reasonable plan so what do I want to do? I want to do call up point N. I want to prove that A and B dash is similar to A and C, and A and C dash is similar to A, B. Well, I know from that A, B dash over A, C equals A, C dash over A, B. So that's quite good and cool. And if I prove that AN over AM is that, then I'm done, and it does work all nicely, and we can do that cool angle thing. But isn't that really obvious? That's really obvious. That's really, really obvious, isn't it?
Wait, what are you doing? What was that?
Proving that semedians and medians are nice under inversion.
Maybe. I'll be honest, I'm doing some random stuff at the moment. Like, I've got a nice skill.
I'm also doing random stuff. Like, you do.
Yeah, I mean.
I suppose usually there's supposed to be more an element of team stuff, but like, this is what basically what we did during IOL.
It's really hard to work together on stuff like geometry because, like.
Yeah. Basically, what we did during IOL was work independently until we found a cool result, then tell everyone what the cool result was, and
that's pretty much what I'm doing.
Maybe divide up work a little bit, and it worked well. So, we take those.
Uh,
Yeah, that's obviously true. dangerous thing to say, but yeah, okay. So
I've returned. What fun shenanigans?
I've proved the median thing, Reese. So
Okay.
we know that M is a symmedian of DB. Like M lies on the No, M is like symmedian. Yeah, M is on the symmedian of DBC. Now, since we've proved that symmedian thing, we can draw that in. We wasn't about to here, and then draw a circle so that X is about there. And then we know, from X being about there, that the angle DXO2 is roughly twice angle CED.
Wait, where are you drawing here? Okay.
And what else do we know about O2? Because that doesn't even get all of it. Oh, bruh. Haha. So, we worked out how to get X. And we haven't worked out how to get O2.
O2 lies whatever, like on the on some condition.
That's a bit of a blur, though I'm quite pleased I got the Simian thing.
Yes, but I'm afraid this is a completely useless answer.
Incredible. It might not be.
Yeah, if I'm happy with it, it's not useless.
Boy.
After all, it means that in the inverted diagram, C is XC is the angle bisector of DXO2, which I'm sure is everyone's favourite fact.
Not Dominic's.
No, not at all. But
Actually, there's like this could be DFF 50 for all we know.
No, it is DFF 51 because it's got angle bisectors and it's plausibly in a circle.
What is DFF 51? What?
Angle bisector meets perpendicular bisector on circumcircle.
Oh. Why is that called DFF? Why is that called?
Dominic's favourite fact number 51.
Oh, okay, yeah, cool. Awesome.
Wait, no, that's not inverted E and D, so that's not true.
So what is it? So what is this diagram then? Is this like our inverted diagram?
Yeah, inverted diagram. L is as you'd expect.
Yep. We mentioned version and AO2 leaves.
Well, he can do that if he wants to. It's his game. No!
Oh?
There we go. So we don't know where on that line it lies, because we don't know DX02 in the original diagram.
I think I'm close. If I can prove one thing, then I think I'm done. Okay, hold on. Thing I need to prove: if you take DEX and DAC, and you find the second point of intersection, I want to prove that. What have you named the intersection point that we need?
We have T.
Okay, T. I want to prove that TD equals T to that second point.
Wait, what? What second point?
So, if you have the intersection of DEX and DAC,
yeah,
that second intersection point, I want to prove that TD equals T to that second intersection point.
What's T then? Wait, what? What's T?
T is the point where all of the lines intersect in the question.
By all the lines you mean
B, C, E, F, and O1, O2.
Oh, that's T, okay.
But specifically T being the intersection of B, C, and E, F for now.
Yeah.
If I can prove TD equals T to that second intersection point, then I think I'm done.
Let's call that S.
Okay, S, sure.
Okay, can I explain why that works, or is it just let's try and prove it first?
Can we try and prove it first? So I am excited for grand reveal.
Okay.
So, what are we trying to show again? I've been out of the loop for the past 20 minutes.
TD equals TS. Look on the diagram.
And what's S?
Look on the diagram to know what. Oh, it's TW. It's W, not S.
Where's T? Wait, what?
Look on the diagram. The old diagram.
The new diagram.
The old diagram.
The old diagram or the old diagram?
The old diagram. Well, that means I can stop streaming, so that's great.
Okay.
Internet didn't die, but whatever.
Oh my god, this old diagram is a complete mess.
Where's W on the old diagram?
Up there.
Oh, W. Oh, okay. You want to prove that TW equals TD?
Yeah.
That does seem like the kind of thing that's provable. Hang on, what?
So you're...
What?
Wait.
That's T lying on the line 0102.
Yeah.
Oh.
Yeah.
Wait. It just looks so implausible from the diagram.
But that's what we need to show. That's what's going to work.
I don't think that's a huge simplification.
I mean, if it does work, we didn't need all of the fun tanty things because we've already got. Yeah, because we've already got the BFC cyclic. So if we prove TW equals TW, we didn't need all the other stuff. I don't think it's possible to do that without doing fun circly stuff anyway.
Can I try fun? I might try. I'm gonna try.
Yeah. Just try it. Try it.
Because I'm so close. I'm so close. I can feel it in my bones.
Right.
This is like the moment of my life.
Okay, we are now at the point where if we were doing it evenly, which no one ever does, we'd be 2 questions in.
Starting. So we're ahead of schedule.
I've finished my chocolates.
I still haven't.
Wait.
But it's quite salty, so I can't have it much of the time.
That is 21 lint. That was very nice. Okay, yeah, Reese.
Yes.
Care to find the angle DX02?
Can I draw a new diagram?
Yeah. Eat your heart out. Actually, that's not that bad.
Wait, was it what did you say? TX02 or DX02?
No. I don't want DX02. I want.
What do you want?
DE02.
DE02. Well, that's that is
DE02 or DO2E or something similar.
Well, they're the same. O2DE and DE02.
Yes.
So the length EO2X is just twice EDX.
Ooh, do we have to trick bash?
No. No trick bashing here. Mind you, I'm not averse to the old like.
Imagine if we managed to solve it with a trick bash, though.
Oh my
That
god.
that would be hilarious, but also people would hate us.
I also can't help but think that the problem 2 solution might have a hole in it because people will complain about it being really hard, but it seems accurate.
Probably a fake solve. There we go. So EO2X is like double EDX, and EDX is bruh.
No, I was thinking we could just work out. Could we? No. Being a fool. Like, if we get an answer for that angle that is in terms of cause and things, I don't think it's that bad. Like, obviously it's really bad, especially for putting in an inverted diagram, but it's also not that bad.
Any ideas?
Plenty, but none that I'm sharing with you. No. I'm gonna invert C.
Because
if it works, it'll be great, and I can't think of anything better to do, and it's kind of a cool mindless activity to do right now.
I mean, we've got like ADC, BCEF, and ABC, so like that's probably a plausible place to invert.
Oh, I wasn't thinking about BC.
I just heard the word invert.
C.
C? Why are you inverting at C?
Because X isn't that bad.
True.
What happened?
It doesn't really help with O2 at all, so maybe it's an awful idea. But I was just hoping that if I find something cool out about W, then the line joining the two centers isn't that bad. So I'm sort of doing it as an indirect way of hoping that something nice will happen. Which is the same reason, I remind you, that we constructed K in the first place, and K turned out to be useful. Because, yeah.
That's true.
When I say same reason, I mean similar reason.
Oh, I'll be right back. Give me a second.
Oh my goodness, I can't draw straight lines.
Hello, then. With your iPad.
Pardon?
Use a ruler with your iPad.
No!
Have you solved it yet?
No, not yet.
Okay.
We've got something.
We have things. We have things that seem fun.
What have you got?
BCEF cyclic and then FED and BCD are both tangent to D at the same line.
Oh, it's like one line to finish.
What?
Right.
Aaron, A, spoilers, B...
I'm joking.
What?
How
Okay.
complicated is that last line?
To be fair, if you write lines long enough...
He's gone. He just came here to gloat and then went.
Yeah,
What
he
is
came
that?
here to gloat
What
and
is that
meet...
last line is double invert and then moving point smash.
No, it'll
How about
probably
we
be a
don't-
trig bash. Like, trig bashing is doable.
That might be trick bash.
For you, I've like.
Yeah, I mean, I'm personally not too huge a fan of trick bashing. Like, I'm just trying to do it with
I've only ever solved one problem by trig bash.
Yes, same.
I think I've solved one geo...
not
I
trig
think
bash.
I've solved one geo that was actually geo past BMO1 without a trig bash.
Wasn't that like problem 1 on the TSTs?
Yeah. That was the very, very... Like, that was the not very hard one.
But like the only other problem, like geo problem past BMO1, but BMO2 problem 3 and TST problem 6.
Oh no, wait, I did solve BMO2 problem 3. That's a good point. I think I used trig. I really heavily bashed that one. Not from the start, but most of it was bash. And there was last year's TSTs as well.
Yeah, when you trig bash problem, there was only one geo, and you trig.
No, last year's second one. Last year's second one.
Oh yeah.
Geo. I just didn't solve it.
I mean, like, how can you trig bash problem 2 from last year? Like, there's such a nice solution that doesn't involve trig bash.
I mean, if it works, it works. Actually, why is the line CF even useful? Okay, so to get the point X, we construct the point M.
Where are we looking now?
Oh, I'm just talking out loud, provide anyone who's watching with some vague interest thing. To construct the point X, well, we can do M nicely, because you know that B will be the midpoint of MC, and then, well... we know that we want to put the perpendicular.
So we're inverting about C. A moves closer to C, doesn't it? And X moves really close to C.
X moves really close to C, but it's also the foot of the perpendicular from M to AC.
Is it? Oh yeah, because inversion angle formula.
Ugh.
So if B is the midpoint of M, right? Yeah, you've blundered a bit then.
Fine.
So
does A go to an arbitrary point? Ooh, the thing about inverting at C is that the point G is no longer that nice. I think.
I mean, like what do we like? We have that ADC, right? Yeah. I don't know. Also, your line's very faint. I can't see it.
Zoom in.
Yeah, but then I don't see the whole diagram. Well, A is between E and X, right?
Yeah. No, that's just wrong. Oh, well, the angle... Okay, the thing is, the angle ADC... Okay,
Yeah.
D could be further out. Like, the angle ADC is
now
nice.
the angle the angle ADC is now like C D prime A prime.
Yeah, exactly. Which is nice. Only it's not. Because nowhere else in the diagram does that appear.
Right.
Really?
Okay.
So that's okay, but only optimal if we can still use other angles that appear in that triangle. Like, maybe... Okay, because we can construct the point K, that's kind of okay, is it? I don't know.
Yeah.
Alright, we'll leave that problem to think about when we actually have to do angle tracing here. So ADC, well, it goes to line, EDX, stays as circle. W. Ooh, and in case you thought the diagram was good, DEF is supposed to be tangent to DBC. You are supposed... Oh no, wait, D... It's supposed to be tangent to DBC. Oh no! DEF being tangent to line DB is slightly possible from that diagram.
Is that meant to be the case, or is that like something?
Yeah.
Because the circle DEF is tangent to the line DT.
And the circle DB. Circle DBC.
Oh yeah. So DB is there. Yeah. Yes.
Okay. And the line DB is tangent to the circle DCT, if we're going to put T in this inverted diagram.
Which, I mean, what good would... Yeah, because T, we want to show that, like, T, D... Oh, wait, no, never mind. Any line not pass... Yeah, we want to show CT, 01 and 02 are cyclic.
And that means that that angle there is that angle there. Which is actually quite nice, because that's DBC in the original diagram, which is actually the yellow angle.
So, now we want to add in 01 and 02.
And that yellow angle is also... Oh no, it's something terrible. It's not like that. Actually, we could... What's wrong with inverting at T?
T?
Oh wait. If we invert at T, the angle conditions around A don't invert that nicely, but we've already used all the angle conditions around A to prove that things are cyclic, right?
Yes.
So the only thing that comes from the only thing we've got in the question that isn't nicely in T is
You're cutting out. You're cutting out. Say that again.
X is okay because it's just T and B and D become a harmonic ratio, and
I'll take your word for that.
Oh no, wait, yeah, and is that all? I think so. Which doesn't seem quite that nice. Yeah, because then we can't get from there to defining. Yeah, because there were no angles involving X and B and C that like PMD that work nicely with. Sure. Okay.
Which question are you doing?
3.
Oh.
We've done 1 and 2.
I heard. I don't know how hard 2 is. I got spoiled on it.
I mean,
It's like 15 solves hard, so it's like.
Yeah, I'm pretty sure. Like, it sounds like I fake solved it, but.
No, I think you solved it. I think I skimmed through the YouTube video. That's correct.
Oh, okay.
That is official solution 1, pretty much.
Joy.
Og.
I mean,
also, if
2 and 3 are showing some matrix as positive semi-definite or something. Or constructing some inner product space or something. I didn't really read
Oh, wow. So that's why people were talking about positive semi-definite matrices at some point.
I know, maybe they were preparing for vectors and matrices exams.
Mm-hmm.
And anyway, so
that's
what we're saying,
that's really cool. Like, I mean, I suppose it's kind
really not cool. It's unsuitable for IMO.
I thought it was a bit like CMC8, if you must know.
CMC8 was vile,
which I liked, and I thought
your script vile.
I thought CMC8 was fine as a question.
My script was awful. I got 5.
I do not relate to this conversation since I did not do CMC.
I mean, like, neither do I.
Anyway, if you've got BCEF cyclic, aren't you basically done?
You said that before. Maybe, but
opinions may differ.
Yes, our mileage may vary.
You're not helping, so please be quiet.
Okay. Samuel, can you not dox me, please?
We shouldn't laugh about it, because it is a serious thing. But also, ha 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 ha.
No. Can you not dox me? He says, using the first name of the person.
I do Bubble Boy 789.
Bubble Boy.
Worries. Whoa, we can see way too much. I'm kidding.
What can we see?
Actually can. We just saw your Discord.
Wait, did you?
That's why you set. That's why you use OBS instead of just see one window.
I mean, like I'm streaming the application window, so like it should only.
But they saw your Discord.
Could you? Can you see it now?
Why are we doing the troubleshooting during the live song?
I don't know. This is possibly the bad time to do the troubleshooting, but.
Okay, consider the troubles well and truly shot.
69 minutes left.
Nice.
Okay, Samuel.
60.
You mean Bubble Boy 6632?
Oh my god, we actually do have 69 minutes left. That's hilarious. Wait, how long have we spent on this in total?
I would say a good 2 hours.
Yeah, 2.5 hours so far.
I can't remember exactly when we finished all
We've made some really good progress here.
No. Okay, yes, that's true, but we also had made that really good progress an hour ago.
That's also true. But then again, this is question 3.
Oh no. I think you solve problem 1, you solve problem 2, then you solve problem 3. That's how the IMO should go.
Yeah, exactly. But to be fair though, there is 3 of us. And we're discussing. So...
Yeah, we solved problem 2, I don't know.
Relatively quickly.
Plus also, I still think I'm really close.
Like, problem 2 just seemed kind of natural.
No, it did not. It felt manky.
Okay, for me, problem 2 seemed natural.
I think it's a bad because you can replace a square root with any convex function, right? Concave or whatever.
Oh my
concave.
god, wait,
Sure.
guys, wait,
Also,
this...
everyone, turn up the music bot, turn up rhythm.
Yeah,
everyone.
hold on.
Everybody's listening.
Yeah, it's mood organ.
It's mood organ. Let's go.
Mood Organ are an excellent up-and-coming indie band.
Yeah, you know what? Everyone, go on Spotify right now. Add this song to all of your playlists. Right
Hashtag shameless ad.
now. Let's go.
To be fair, they are a good band.
Friends with someone in the band.
This Livesolve has been sponsored by Mood Organ. To be fair, they better give us some royalties after we just plug their band.
Yeah.
No.
We expect money.
Yes, because they get royalties. I'll send you exclusive backstage photos from when I meet up with them. Okay, back to problem thinking.
Oh my god. Meet up with them exposed. You weren't supposed to reveal that.
Start sweating.
Relation in my skull. Would be a wonderful greenhouse.
Amazing. Whatever.
What to do about the double glazing? I'm tired.
I know my way around.
Not now. I'm tired. Not now. I'm tired. Okay, back to maths. We doing maths?
Yeah.
Okay, so what was our angle condition again?
Okay, we want to find angles around O2, E, and D.
D being the intersection of AD and BC. Not now.
What are E?
I'm tired. Oh, E. Not now.
Because once you've got that, Kieran can angle take it together.
Yeah, let's go! Angle chasing. Go on.
I mean, you're really good at it. It's a skill. Be proud.
Shame it's the only thing I'm good at.
Destroyed. Okay. So what are we doing again? We get sidetracked way too easily.
3.
I know we did question 3.
Being an IMO Livesolve, Bruce. How would you forget?
Please just shut up.
Ouch, my feelings.
To be fair, if we put like K or L in,
K being the intersection of AD with DBC.
I'm just thinking the
So K
M could be
like
Simpson lines.
Simpson. Wait. Hold on. It means that like. So the circle DBKC maps to a line DBK, right? So K lies on DB. It also lies on the circle. So it's K is second intersection of a line BD with a circle ACD. Hold on, but the circle ACD has its circles in it in the pre-inversion.
That's because you're wrong. It's DBC, which is line DB. And otherwise...
Okay, no, hold on.
Yeah,
the line AD
you are right.
to the circle.
You are right, but is that helpful?
I don't know, probably not. And L being the intersection of AD with the circle ABC. So that would mean that L would be the intersection of the line AB with the circle A. The line AD, like the circle ADC has like lots of points on it.
The issue is that wait, O1 is nice. I'm just going to assume O1 is nice in this diagram, but O2 still isn't.
Yeah, it like.
Grrr. Back to the drawing board. The thing that's really annoying me is that we don't even know if EF0102 will be cyclic.
It will be, right? Because oh wait, no, it won't be.
No, it doesn't have to be.
No.
It could be something stupid, like the other point opposite, like the intersection of O102 with EDX and O1 is cyclic with EF. It won't be, but it could be. So that's why it's cooler to invert and then prove parallel. The issue being inverting and then proving parallel is difficult.
Yeah.
Okay, so I'm trying my best not to mindly panic right now, but if you'll cast your eyes to the diagram I've just drawn, I think I've solved it.
Okay,
wait, which diagram?
Casting eyes.
Okay.
Okay. So I've drawn.
Is this post inversion?
No, this is pre-inversion. I've drawn the Mikel point of BCEF MI. I've also done I've done this in the case where
X meant is.
Yeah, I've done this in the case where AB is less than AC because X is in a nice place, and I'm pretty sure all the math still transfers.
Yeah.
It's just that X is in a nice place.
Did they only put that to make sure that you didn't get X equal to A?
Well, yes, partially. Okay, here we go. So, MI, I called it MI because it's Mikel point of
Mikel point of which triangle?
BCEF.
Wait,
So
you have Mikel point of a circle?
It lies on AEF, it lies on FBT, it lies on ECT, and it lies on ACB. Right?
Right.
That's the thing.
Say this again. I'll write them down.
Okay, so it lies on AEF, it lies on ABC, it lies on TFB, and it lies on TEC.
So is that like a lemma about
TFB, sorry. TFB.
Okay, yeah.
And TEC.
Is that like
yeah,
a? Is that
yes.
Yeah. Okay.
Yeah, that is
well-known probably like a complete one.
And then I did I dropped my mouse. I am shaking very heavily right now. Hold on. Okay. So I have that is yellow. I do not want it to be yellow.
Go blue.
Yellow. Hold on. And there we go. So BMIE equals 180 minus AMIE minus.
Is it? Oh yeah. Wait, is it? Oh yeah.
Yeah.
Yes. Yes.
Then AMIE is equal to AFE.
Yes.
Yeah. Cyclicity, which is equal to ACE.
Yes.
That's 180 minus C.
Oh.
And TMIB is equal to TCA because ACB MI is cyclic. That's minus C. That's 180 minus 2C, which is equal to AXB.
Wait, MIABC is cyclic. Why am I being a fool?
Yeah.
Yeah, because like it's defined as being on MI.
Yeah. Because
A equal.
Yeah. Wow.
I'm so which equals 180 minus AXB. Sorry. There we go.
Why? Why is that? Oh yeah. Wait. Why does that hold again?
Because XBC is equal to XC.
Oh yeah.
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 And therefore, BMIEX is cyclic. Right?
Yes.
Okay. Epic.
Wait.
X.
Hold up. I'm still pretty slow. Yo. Sure, okay, yeah.
Okay, so I've defined L as the intersection of AC and MIB.
Yeah.
Okay, so we have, I'll write it over here now, LE times LX equals LMI times LB.
Wait, but that's also equal to LA times...
Which equals LA times LC, yeah.
So harmonic range?
LD, sorry, both. LD lies on the radical axis of DX, DAC, and MDB, MID.
Wait, hold on. Slow down. D lies on the radical axis of.
So L lies on the radical axis of DAC, DEX, and DMID.
Because.
Yeah,
okay.
Right? Hence,
the
three circles are all coaxial, they pass through a second point. You call that point S, right? I think you call that point S?
Yeah. Or it was W.
W.
Okay, W. Awesome. W. Now, invert a T, radius TD.
Right?
Okay. Radius what?
TB.
TD.
I'll turn the monetary pictures down.
Okay. Invert at T.
Oh, so inverting at T was something.
TD.
Okay. Wait, hold on. The circles are coaxial. Wait, are they?
Yeah, because they have radical axis at D out. So they must all pass through a second point.
Is that like part of the definition of coaxial?
Yes.
Yeah.
Okay.
So inverted T radius TD also equal to
TD
of TF times TE also equal
to
by
the
TMI times TA and
also
TE
equal to the square root. Yeah.
Therefore BMID, the circle, gets sent to ADC and vice versa.
So does
therefore
the
that second
circumcenter
intersection point W is fixed. Therefore it must lie on that circle radius TD, hence TD
which means
TW, hence done.
Wait. BMID gets sent to ADC because W goes on both those circles. Does it lie in both the circles?
Yeah, W is defined as that second section point.
Second section point of the circles ADC.
ADC,
okay.
DX, and now MDB is MIDB as well.
Yeah.
That's very cool. That's very, very, very cool. Wait, how did the US do on this problem?
I don't know.
Search it up.
I think I think anything we do now is just writing up stuff, and Aaron's nicely spoiled that we don't have to write it problem 2 very nicely. But yeah, I want to see how the US did on problem 3 because complete quads, assuming they have loads in selection tests. Okay, so they did do awesomely, but also people solved it.
Wait, let me have a look.
Okay, Luke solved it. I know Luke and Geo, and Ankit Bissain is someone who did well in the
Geo. What do they get? 2 7s, 3 1s, and 0.
Yeah, 2 7s, 3 1s, and a 0.
Okay.
What? Whom?
Yeah. 7s were
America
Ankit
got.
Yeah, like Luke, I know does Luke's good at everything, but is scarily good at Geo.
Okay, so
and then Ankit does. I think Ankit does a lot of Geo on IOPS and stuff.
If we're doing write-ups, shotgun writing at problem 1.
Bruh, okay, well I'm shotgun writing at problem 3. So Frith, that leaves you problem 2.
Yeah.
That's not a problem. I like problem 2.
Alright, wait, where are we writing it up? Are we writing it up on paper? Or...
We should write it up on the whiteboard, really.
Okay. Yeah. We can add in text and stuff.
Dreadful.
You basically solved problem 3 solo.
I did.
Yeah.
Literally shaking.
I think it worked well because I think I got most of 1, Thomas got most of 2, and then Kim got most of 3.
Yeah, I kind of independently solved 1 just on the right hand side.
Yeah, but give me some credit, okay?
Reese got some credit. Reese gets some credit for that. He did do a bit more. I'm happy to announce that I did pretty much 0 of the work for 1 and 2. I was just kind of sitting there
for 3, I did the all-important bit of constructing K.
True. You constructed K. That killed BCEF cycling. Okay, right. What am I doing?
Those of you who don't want to see problem 1 probably don't watch my stream.
Yeah. Okay. I'm gonna try and write up problem 2.
Okay,
I'm really bad at write-ups, but
same.
Feel free to watch the even cooler Danielle stream if you want to.
Yes, if you don't want to see problem 1.
If you want to see the attempt to write problem 2.
Okay, I'll do it.
Okay, right. So.
No, that's my bit for problem 2. Look, that's literally underneath where problem 2 is, Kieran.
Wait, is it actually? I can't. Oh yeah, it is. Whoopsie daisy. Sorry, I will move across.
I have to zoom in further.
I'll just do it underneath my other diagram.
Oh, but yeah, I have to use latex.
Alright, so...
Okay, wait, do we try and explain our write-ups, or will it just leave us all talking at the same time?
It will leave us all talking at the same time.
But you can't talk, because you'll spoil it for some people.
Yes.
I can talk though, because it's been a while since you've problem too. And it'll only confuse you and Kieran.
Yes.
Okay, so I'm now just trying to use posh things to make it simple to understand. So first I'm defining the construction into a start and differences. A corresponding set by ordering set in weekly increasing. Then let A E equal then let A equal y1.
Why? Didn't you hear what we said? Just you wait for his end. Just you wait for his end.
Okay, so you've done the important, like, maybe the first cool bit of the problem is realizing that constructing this corresponding set is actually really useful because it removes most of your doubts about parity.
You mean signs?
Yeah, I mean signs. This construction is many to one.
Are we all watching the question 2?
Well, if people don't want to be spoiled by question 1, then they don't. Just don't
Yeah,
streak.
Right. I'll do the question 3 one after you do the question 2 one.
Yeah, I mean, I don't know. Problem 3 is probably very cool to watch just because of, I don't know, like the BCEF cyclic is solvable by most, or is like appreciable by most people.
Yeah.
And then Kieran's last bit is just epic.
Yes.
I'm very proud of that ending.
Yeah.
I don't know how to read quadrilaterals work, so I'll just leave you to it.
I mean, they're in EGMO.
I know,
Yeah.
but do you think I'll be bothered to read EGMO now? I'm about to go to university.
Well,
I mean, I need to have my copy.
You just do it, Pepe Face.
162 minus is 126.
So now we do boring stuff. Yeah, okay. You know what? If IMO Day 1 had been a UK TST, this would have been grand.
Yeah.
Yeah.
Because it had a relatively easy problem 1, a sneaky, disgusting problem 2 that Thomas can easily bash.
This? Excuse
What?
me? This is beautiful.
To be fair, Frith, it is a little tiny bit gross.
Yeah, I mean, I concur it is a tiny bit me for a problem. But that doesn't mean it's bad.
True. Wait, I do have to ask, does 9271 context mention a theorem called DIT? And I do not know.
It's something to do with complete quadrilaterals, I think.
What did you say?
He mentioned something called DIT, which apparently is just an overpowered theorem that kills question 3. What actually is it? What does it stand for? I do not know.
What? Wait, DIT? What?
Yeah.
Absolutely no clue.
Lovely. He's mentioned a theorem, nobody knows what it is. Brilliant. And
Hang on, are you just looking at solutions now, Kieran?
No, I'm looking at the
No, reading the Livesolve chat.
Oh. Who said DIT?
9271 context.
Oh, okay.
So if you didn't use DIT,
Kieran will... Okay, 9271 will definitely just know that as a thing.
Yeah, to be fair, that seems like the kind of thing he just knows.
2.5 years ago, 2 years ago and a bit, he didn't know Pascal's theorem, and I'm still proud that I knew something that he didn't in geometry. Because now,
knew Pascal's theorem.
Now he's just so far ahead.
I learned Pascal's theorem in Hungary. It was the only thing I remember from the projected geometry lecture.
Oh my god, yeah, same. It's literally the only thing I remember from Hungary. It's literally the only thing I remember in general from Hungary now.
No. Do you remember from Hungary? You passing out next to me. That was scary.
Oh shit. Yeah, that was a thing that happened. I blocked that out of my memory. Yeah, I passed out hungry in the middle of a lecture.
And I was next to him like, are you alright? No, you're clearly not alright. What do I do?
And I woke up and I was fine. But, like... that was strange. I don't normally, for the record, I should state, for the record, I don't normally pass out in the middle of lecture. If I remember correctly, I got like a weird tummy cramp, and then it hurt so much that I passed out or something.
This was just after. This was also just after someone else was sick the night before.
Oh yeah. This was after the first person, like, threw up during a game of Babylon.
That was traumatic.
That was traumatic. To be fair, that Hungary camp, there were so many illnesses. That was like pre-COVID as well, so we can't even blame it on COVID.
Yeah, and the COVID it doesn't induce vomiting, so
yeah.
Well, yeah, I'm blundering this right up.
Let's go.
I'm actually using words.
Oh my god, he is using words.
No, I'm using words. I think this is like, apart from the fact that I just wrote if needed we could, everything's great.
When you say given a corresponding set, do you mean A plus D1, A plus D2, all the way to A plus D2?
No, the corresponding set is a D1, D2. I defined it earlier.
Oh, I see. Oh, okay, fair.
Like, I've got headings.
You do have headings.
Yeah, I don't.
Very correct. Oh my god, why does your could look like COVID? I'm just seeing COVID everywhere now.
To be fair, like, actually, how hard even... I don't think this is that hard for us to motivate either, like, it just felt natural.
I mean, I'll be honest, like, when I saw this problem, I did not immediately think about proving that there exists a worse set. Like, my brain was more going along the lines of trying to find some sort of induction, but, like, it's very hard to prove that.
Well, the reason I was thinking a worst set is because it's kind of natural to say, well, if I have a table of absolute values and I can let the minus signs vary, which one's worst? And then we were also thinking, hang on, but we can scale it and it should still be okay. So, yeah. Combining the two was just sensible.
I love the phrasing. We claim that that value exists. Not as a tends to infinity, which is obvious, as when a tends to infinity or minus infinity, everything gets really big.
Hey!
Yeah.
Hey, and then I define it actually.
Okay, if we need between that. Okay, I see. it gets big, okay?
M plus 4M plus 4, so that's 2M minus the 2M.
Actually, how do we prove this? Because the way we proved it before was saying calculus, or you could just look and say it's obvious. But the reason that it's obvious maybe isn't that plausible? Maybe we do just differentiate.
Why? No. Bad. Bad.
Okay, so I don't know how to write that nicely, so I'll put like bad on one side of it, so everyone knows. Oh no! I've got good on it. It's fine.
Minus 4M on this side. Over 8. It's 8.
We've got a whole 30 minutes left. This is banging.
This is banging, I agree. We actually kind of popped off for morning.
Yeah. I am grateful that
Why are you doing problem 4?
Doing problem 4 on Friday.
No, we have a separate. Okay, we planned to have a separate live solve for that. Like, I've got days and days of nothing to do. Apart from, like, other things. But quarantine fun, I'm going to advertise it, because, hey, come to the UK after you've been fully vaccinated, when you're travelling from a place that has so, like, incredibly low amount of COVID cases, and then you still have to stay inside, where, like, I'm more likely to get COVID by, I don't know, walking a mile outside than I am in where I lived in Canada. That's true.
Reese, was that you who wrote the word bad?
No, it wasn't.
No, it was me. I wrote the word bad because I had a bad argument and then I realised a good argument, but I haven't raised bad yet.
Oh.
Would someone mind, like, I've managed to, like, latex my write up.
Bruh.
Uh-oh. I might have made it very big. Oh, you're actually writing. Okay, I typed it.
You don't get to type in the IMO, Reese.
So?
I don't know. I need to learn latex.
Can someone read my write-up to check that it makes sense?
If you post it, have you posted it on the whiteboard?
Yes, it's on the whiteboard.
I'll look at it when I finish writing up this.
Okay. Kieran, have you written yours?
Not yet, I'm waiting for him to write his. Should I be writing mine now?
I mean, yours isn't that, it's not that long, is it?
It's not, it's really not that long.
Yeah, exactly. A value.
I'll try reading it. Yours.
I've done the diagram. So I can keep writing it up now if you want.
Yeah.
Ooh! I'm gonna alter this. We cover all n-tuples in corresponding sets. A weekly
you're right.
increasing order, then Well, that's a nice way of saying it. Because now saying we cover all the n-tuples is nicer. That in the in an n-tuple covered by the corresponding set disproves the if and only if there exists a disproof within that corresponding set Y1, not X1. Y1's after ordering. Oh my goodness. Why would anyone ever write problems up?
But yeah, so basically you're saying that at every end you can like reshuffle it to get like the worst possible set.
Not reshuffle it, but like Yeah.
As in, like, if you move it around by a sum, it doesn't really change it. It doesn't really change much.
Okay, yeah, fancy looking over the proof?
I have read over it quickly. I just need to check you out on the last part, and the rest of it makes sense.
Okay, I'm gonna look over your proof. Oh, you did do it by induction. That's so weird. What is this?
I tried some weird induction that basically says that either you can add one to it and everything's fine, or if you don't, or if you add one to it and everything's not fine, then everything becomes fine when you like move.
Add more than
+2.
Okay. Wait, what? Reese?
Yes?
What?
Over there now.
That okay, your either m squared is less than 2m just isn't true. Oh no, it is true because you're inducting +1.
Yes.
Sure. That's very nice. Much nicer than my like straightforward. Hey, let's prove there are at least 7 consecutive squares in between these two numbers, and therefore we're done. Because especially given that actually doesn't work until like
m is 150.
Until high numbers. Way more than 150. Yeah, I think it's. Oh, okay. Something's wrong with the bounding there. Meh.
Wait, is there something wrong with my bounding?
No, something was my bounding, not yours.
Okay.
What's wrong with my bounding?
Oh, wait, no, it should be a plus. Change that. It's 10 + 8. Which is still true, but.
Two consecutive squares between 2n and 4n, or
you want 3 consecutive squares between.
No, I want 7 because I want them to be even.
Oh, so you want there to be 3 even squares between.
Have you heard back from Esper yet, Thomas?
No.
Okay, well, no one has. So, well.
Yeah, but I want to plan my summer.
Yeah, that's what I'm thinking too. Like, they're leaving it awfully late.
Also, don't answer. Okay, like answer like you want. But where do you live, Sam?
Dude, I'm literally on YouTube. I'll message you on Discord.
Yeah, I was gonna say like, DM probably works better.
Yeah, I'm just flexing that Sam trusts me that much. Yeah, that's just a dumb bound. That's like not useful. It would have to be. Well, worst case scenario is m-1 squared is 2n plus 3. No, worst case scenario is m-2 squared equals 2n plus 3. Because I want evens. So then I'd want to have... I still want to have, like... m plus 6. I still want to have m plus 5 squared is less than 2m minus 2 squared plus, sorry, minus 2. Which is actually a nicer bound, and so everything is completely fine and the solution still holds. That's a much nicer bound, actually. Oh, cool. Yeah, so that's the cool thing. And it was m plus 4 squared as well. So I realised that might fail on the basis that m squared... I mean, not fail, but it doesn't make full use of what we know because m squared could possibly be anything. Like that just shows that there exist some m that would fit in the range, not that every range has m that fit in it. But this looks at the worst case scenario and proves that it doesn't hold. And it's only slightly different, but... Oh, I think I get what they got. Yikes. Oh well. No, I don't. I get 10. I get 10, which is... a nicer bound by a whole 2. We take those.
Oh, okay. I think I've finished my route.
Do you want someone to proofread your P2, Thomas?
Yeah.
You three should
I'll attempt.
I'll attempt. Samuel thinks.
I'll attempt to read
Aaron,
it.
what do you think of the key free solution?
Like
what?
What do you think of the key free solution?
I think it's worse than my one, which is cleaner.
I have not seen your one. What is your one?
Like,
so you know, once you have, if you apply, I think what you called T, I called Y. Let's call it T. If you apply Desar's involution theorem to like F.
Okay, hold on. What?
B B F Y.
No, that's not.
What?
Desar's.
Yeah, apply Desar's involution theorem to FYBB or FTBB.
Oh, that's DIT. Okay.
Yes.
I have never heard of that theorem before. Hold on.
How have you not heard of it before? It says that like if you have a tonic and an inscribed quadrilateral ABCD, and you have a line L that intersects like the tonic in 2 places and opposite sides in 2 places, then on that line, like those pairs of points are reciprocal pairs of an involution.
Okay.
Ah, yes.
I'm gonna pretend like I know what that means. Continue.
I mean, also, Aaron, did Samuel actually think that? Because, like, nah.
Oh, no, he didn't think that. I just made that up.
Yeah, I thought you did. Like, selection tests are a fair way of doing things, even if annoying, because fake solves. Yeah. I still think that first round of TSTs, that Trinity should be harder. But
I mean,
yeah, like
there are arguments for and against that.
exactly. So
arguments for and against
Also,
what?
I can't talk about the TSTs.
yeah, I know you can't. But
Because I've marked them. So
that means I can still speak about them, and you can't come back with anything reasonable, which is
I
excellent.
might just leave the call like now.
Oh, okay.
You can. No, nobody stopped him.
You know, he just did.
Oh, he just did. Okay, I see. Very
But
good.
yeah,
I can't read it, by the way.
you can't. Oh, you're looking on my screen because you don't have the link.
Yeah.
There we go. Can you read it now?
Yeah, I can.
Let me take a look at Fripp's one because I haven't.
Also, that is A.
I have not seen it yet. But I'm very lost.
Like, I tried to make it so it reads pleasantly rather than assuming you know what's going on in my head. But oh well.
No, it sounds about.
I'm just really happy. I solved something that Luke Robitaille didn't.
Oh, Leah, I'm probably gonna get 2.
Yeah.
Wait, that who didn't? Sorry.
Luke Robitaille.
Oh,
Yeah.
fair.
Like, I almost got Q10 at the HMMT thing, and then just didn't. And he didn't get that one, but... Hey. Weird algebra that involves lots of x's, my favourite kind. Okay, Sam, do you want me to scroll down?
Yes, please. Yeah, scroll down to in the worst set. Go up a bit. So like, yeah, okay, that's fine. Thanks.
Bro, I'm actually looking at Luke's records in previous IMOs. He has actually gotten 35, 36, 36. 3 years in a row.
Yeah, he got next year as well.
Oh wait, he's year 12 at the moment, technically.
He's a bit of a beast.
Wait, what the heck? He's my year? What the hell?
Well, some people are good.
Yeah, that's
He also
freaking insane though. What the heck?
he's also homeschooled.
Oh, okay, I mean, to be fair, I expected that. Like,
yeah.
all good people are homeschooled. That's insane,
Yeah, Sam.
though.
That's what I thought, and I said that because I know some people who live there who like, I don't know, they want me to say hi, and saying hi to multiple people in what it seems good in one trip.
Yeah, sure. I'll come along.
It's weird though, because only one person got full marks, as opposed to last year, which many people got full marks.
Which is excellent.
No, last year only one person got full marks.
Wait, what?
Wait, what are you talking about?
Oh no, only one person did get full marks last year. I must be thinking of a different year. I swear there was one year where like almost the whole Chinese team got 2019
possibly.
Yeah, 2019. Literally the whole Chinese team, or pretty much the whole Chinese team. Well, they got very close at least.
But yeah, does that make sense, Sam?
No, I'm still reading like this claim and just like has a
okay.
There's quite a lot skipped.
Oh, I solved math problems.
I'd be quite surprised if you didn't solve the maths problems. Do China ever have the same person 2 years in a row? I'm looking through and they literally have never had the same person 2 years in a row.
Yeah, I think it's a rule.
What?
That's a weird
No.
rule.
Not really, given their population.
Surely you just take the best people, whether or not they've been to an island before.
I mean, if you have like people at like, I don't know, 50 people that are gonna get gold medals, you might as well just try and give everyone a chance.
That's true.
Request. Wait, I don't know if it's on YouTube, but request to change the last song of the Livesolve to Mood Organ's Affirmation.
I don't have access to change that, but I can.
I think someone does.
Can I like, oi, at inverted Diablo Nemesis XD, we require your assistance.
Yeah. Sam, does that make sense? Like, do you understand it now? Or do you want me to try and like verbally explain?
I think it makes sense.
Like,
I get what you do. I'm just like deciding whether like there's enough justification for it.
I think
it's fine. It doesn't matter.
All the square roots will only go down until that's happened. After which they'll only go up.
Yes.
That's it.
Okay, yeah. So therefore, like, how did you determine the minimum has to happen when like A equals DI plus DJ?
That's when the modulus is around a 0. Like,
so, yeah, the modulus is 0, but like, how do you know that weird derivative stuff doesn't happen in like in between?
Because when you're bruh, that's a good. Wait.
No, like.
No, it's a good point. I did think of that and then went. That's why it was a bad description in the first place.
Like, yeah, but
I don't know how easy it is to fix, but like, what you're saying is like right, but it hasn't like.
Yeah. No. That's why I had bad written next to it in the first place. Because small stuff has bigger change than big stuff. Because no, because that's the only reason that the gradient ever changes. No, that's not accurate. Meh, I don't know. I thought that if anything solved it. Well, joy.
Oh, I got dinner. I will ask Adi to admin or moderate or whatever. Where he's went to sleep.
Oh my god. Oh my god. We literally have been doing this for 4.5 hours. That's how long the YouTube should be going for.
Yes.
That because then that also could put 90 minutes in the top 3 times.
Yeah. Oh my god. I don't think I've ever done maths for such a long period of time before.
Okay, the reason that it works, which I don't think I'm going to write down, is because I think the amount, like, if going that way by, like, t changes all the numbers that are negative by, like, by s, then it'll change all the numbers going that way by, like, some other number, like a, but then changing it a little bit more will change that by more. Right? Does that really help though? No. Yeah, because if you move it a little bit more, then that next bit will change by more, because it's going down, which is like always steeper on the graph of root x. So, like, so if we're moving it by t1, then we're moving it by t1 again, and we don't change, then, like, s2 is bigger than s1, well, a2 is smaller than a1. So, given that it's always positive and we're looking for the smallest value, the only reason for it to actually get actually lower, or for it to stop getting more actually lower, is for one of those to change over from going down to going up. Otherwise, you can keep adding on small bits and it will just continually get lower. So, that's the reason why no weird shenanigans happen, is because the graph of, like, the graph of y equals root x is decreasing, like, because the graph goes down. Joy!
Wait, so, like, if you have a load of little things increasing by little amounts, and then one thing decreasing by a big amount, how do you know the lots of little things increasing doesn't add up to more?
No. But I've already said that, like, you've already, if you move it up by so much, and then by so much again,
where's Samuel?
The amount you move the second time will be less compared to the first time.
Guys, do you know where Samuel is?
Outside. He's just left.
He's gone for supper.
Just gone.
What an idiot.
Wait, so...
Yeah, it's fine. We fixed the hole in the last.
Wait. Say it again.
Also, Aaron,
okay, so when you increase a by e1, you decrease all the small things, all the things that are like negative like the modulus things that's negative for the positive by s1, and then when you do it again, you change it by s2, where s2 is bigger than s1.
I think so. Are you saying that, like,
the amount
you can't have them
you increase it always increases, but the amount you change the positive one when you increase it always decreases. So therefore,
okay, so you can get a change of direction of travel not at one of the points you said.
Can you?
There's a subtle. There's like a really. Or at least I'm fairly certain.
I don't think so.
Wait.
The only way.
Yes, I think I can, with some effort, come up with an example where you do get a change of direction of travel.
Like, if you say you can, and, like, I don't think you can.
I'll get something on Desmond in a second.
Yeah, no, because like basically the direction of travel is determined by how many of the A's, if you like, are positive, right? Based on the absolute value thing.
Not necessarily, but like the relative amount that the negatives one changed and the positive ones changed is. Like, you can change the direction of travel. So you can change the direction of travel, but you can't change, like, the direction of travel.
Okay,
Oh,
yeah,
yeah.
I've got an example.
You
Do you want me to
differentiate
take a
twice
picture,
and it works
Thrift?
nicely, that's why.
Thrift, do you want me to take a picture and send it to you or something?
Yeah, go for it.
Or actually, no, I'll...
No.
This is massive. This is kind of bigger spoilers at this point. You are like really close, but
you differentiate
what you said
twice and
isn't
it works
actually
nicely.
true.
Pardon?
Pardon? What did you say?
You differentiate twice and it works nicely. That's what I'm arguing.
Exactly it. So you say it's piecewise concave.
Yeah, that is the thing that I'm saying here.
Okay, because the point is you can get a change of direction, but if it's a change of direction because it's concave, it's a minimum. Am I assuming the right one? Yes. Yeah, here. So you can get maximums.
Where is the here?
So this is x minus 1, x plus 1. This is a change of direction, right?
Where is the here, Daniel?
What do you mean? What?
Oh wait, can you not post on the Myro thing?
I'm streaming. I could, if you just join the stream.
No, because I'm streaming.
Oh right, so you can't join us. Okay.
Yeah, you can.
Yeah. Okay. The thing I was arguing was piecewise concave. That's fine. That's great.
Yes, the concave argument works. Indeed.
Okay. I think
George.
But wait, I'll DM you picture then.
No. Yeah. That's not what I. Yeah. When I said change of direction, I wasn't arguing. I don't think I was.
Basically, there's a maximum here, but the point is.
Yeah, I was arguing change of direction in the change of direction as in it starts going. Yeah, okay.
Questionable write up, but yes, I
wrote up the thing that was relevant, which was the S1 and then S2 and T1 and T2. And by wrote up, I mean I wrote it down in 5 seconds and had those thoughts before it ended.
Yeah.
Which is all you need.
So, I don't know, whatever. Either way, even if you don't do that bit, you should get at least 3 points.
Yeah.
Did you sign up to Esper?
Yes, and no, I haven't heard anything yet.
Okay, well, I have.
Wait, as of how long ago?
8 minutes ago.
Okay, well, I still haven't, so yikes.
Do you want to refresh your emails?
I just did.
Oh, weird. Or maybe they're staggering them or something.
Yeah, did you get in then, Aaron?
I did get in.
Yes. Well, that means
anyone else apply? I know Samuel did.
Yes. So is that why you came in here 8 minutes ago? And said,
yes.
Where's Samuel? Okay.
I just don't care so much about you. Sorry, I'm joking. I didn't know.
I understand. It's fine.
I didn't actually know you'd apply. I just thought maybe you might have.
Well, Espar responded to me like a month ago, rejecting me. So.
What? Straight up rejection? Wow.
Same
as did Daniel, I think.
What? What is up with that? Wow, that is weird. Did you meme on the admission? I memed on the form.
I didn't meme. Wait, when did you submit? I submitted very early. As soon as the first announcement was put on announcements, I filled in the form, submitted it in.
A week and a half ago.
All right. Okay. wait. When was the first? I submitted in the 12th of June.
You know the form about what's one superpower it said your friends have or something?
Oh yeah.
I wish I was able, some of my friends seem able to not procrastinate. I wish I could do that. And I think about ways I could do that, but I'm not very good at putting them into practice because I'm answering this question half an hour before the deadline.
I'm gonna end the stream, but
is that even memeing though?
Because